champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So today we are going to discuss NEET 2018 physics questions and we are 45 questions here. So let's start the session. The first question is from the chapter Waves and the question is a tuning fork is used to produce resonance in a glass tube. The length of air column in this tube can be adjusted by a variable piston. At room temperature of 27 degrees Celsius, two successive resonances are produced at 20 centimeter and 73 centimeter of column length. If the frequency of the tuning fork is 320 Hz, the velocity of sound in air at 27 degrees Celsius is. Okay. So first of all, we have to remember that temperature has nothing to do here. Okay. The velocity is temperature independent. Now, what are given in the question? Lengths are given. To L1 is 20 centimeter and L2 is 73 centimeter. Now, what are L1 and L2? See, in the first resonance, that is this one, fundamental one, we know that length is equal to lambda by 4, right? This you have to remember. So this L1, that is 20 centimeter, is nothing but lambda by 4, okay? And in the second resonance, that looks something like this. The length is equal to lambda, 3 lambda by 4, okay? So 3 lambda by 4 is given here as 73 centimeter. Now, if we find the difference between these two lengths, suppose this is L1, this is L2, then the difference, that is L2 minus L1, will be equal to 3 lambda by 4 minus lambda by 4. That is equal to 2 lambda by 4. Okay. And 2 into 2 is 4. So it will be equal to lambda by 2. Also, we know that lambda is equal to velocity by frequency. So we can say that lambda by 2 is equal to V by 2F, right? Now, let's write it down here. Here we can write that the difference in length, that is L2 minus L1, is equal to V by 2F as we have found out here. Okay. So what will be the value of V? It will be equal to 2F, that is 2 into frequency into the difference in length L2 minus L1, right? Now, so we have to find out the V here. V equals to 2 into frequency. So frequency is given. It is 320 Hertz. 320 Hertz. And L2 is given as 73 centimeter. L1 is given as 20 centimeter. And since it is in centimeter, so to convert it into meter, we'll write 10 to the power minus 2 here. Okay. 2 into 320 into 73 minus 20 will be 53. Into 10 to the power minus 2. Now solve it. On solving this, we'll get 339 meter per second. Therefore, option B will be the correct answer. Now, question number 2 includes concepts from the topics electricity as well as motion. And the question is, an electron falls from rest through a vertical distance small h in a uniform and vertically upward directed electric field E. The direction of electric field is now reversed, keeping its magnitude the same. A proton is allowed to fall from rest in it through the same vertical distance h. The time of fall of electron in comparison to the time of fall of proton is. Okay. So what is being said in this question? See, in first case, an electron falls from a height h. Okay. And the direction of the electric field is in the upward direction. So this is the electric field. Okay. This is for electron. Now, in case of proton, the height is same, that is h, but the direction of electric field is reversed. Now the electric field is in the downward direction, right? So here we have to compare the time of fall of electron, that is Te, and the time of fall of proton, Tp. Okay. So let's see how can we do this. First of all, we know that we have the equation for distance s equals to ut plus half at square. Okay, you must be aware about this equation. So s, that is the distance, is h in this case, right? Initial velocity will be 0, so this whole part will be 0 because it falls from rest. So h will be equal to half at square. Now we have to compare the time, therefore we'll find out the time. So t square equals to 2h by a. So T is equal to under root 2h by a. Now h is the height, but what about the acceleration? What is the value of acceleration here? We know that acceleration is equal to force divided by mass. So in this case, since charge is involved and electric field is also there, so force will be equal to charge into electric field. So acceleration will be QE by m. So let's put this value. T is equal to under root 2h by a. In place of a, we'll write this value QE by m. So it will be 2h by QE and m will go up. So this. So time is equal to this formula. So here we can see that in both these cases height is same. Okay, so height will not vary. Charge is also same for electron and proton. Electric field is also same. Okay, the direction is different, but the magnitude of electric field is same. So time will vary with mass only. Okay, only the mass is different for electron and proton. So time will be equal to will be proportional to root m, isn't it? Now we have to compare the times. Time in case of electron divided by time in case of proton will be equal to under root mass of electron, and mass of electron is 9 into 10 to the power minus 31 by the mass of the proton, that is equal to 1.6 into 10 to the power minus 27. Anyways, we can see that the mass of electron is much smaller, right? So mass of electron is much smaller as compared to the mass of the proton. Therefore, time for the electron will also be smaller as compared to the time of fall of proton. Okay. So the time of fall of electron is smaller, and here it is asked the time of fall of electron in comparison to the time of fall of proton is so smaller obviously. So option A will be the correct answer. Question number 3 is from the topic simple harmonic motion, and the question is a pendulum is hung from the roof of a sufficiently high building and is moving freely to and fro like a simple harmonic oscillator. The acceleration of the bob of the pendulum is 20 meter per second square. So the acceleration A is given at a distance of 5 meter from the mean position. So this distance x is also given. The time period of the oscillation is, we have to find out the time period t. Okay. So here we know that the formula for the acceleration, the magnitude of the acceleration is equal to omega square x. Okay, this is simple formula that you have to remember. Acceleration is already given here, it is 20 meter per second square. Omega square is not given, but x is given, it is 5 meter. Okay, so we can find out the value of omega from here. Omega square will be equal to 20 divided by 5, that is 4. So omega will be equal to under root 4, that is 2 radian per second. Now we have to find out the time period, and we know that time period is equal to 2 pi by omega. Again a simple formula. So let's put the values. 2 pi divided by omega, that is 2 radian per second. So here we'll get pi and the unit will be second. So pi second will be answer, that is option B will be the correct answer. Question number 4 is from the topic capacitance, and the question is the electrostatic force between the metal plates of an isolated parallel plate capacitor C having a charge Q and area A is option A independent of the distance between the plates, option B linearly proportional to the distance between the plates, option C inversely proportional to the distance between the plates, and option D proportional to the square root of the distance between the plates. So basically we have to find the relation between the electrostatic force, that is F, and the distance between the plates. Okay, so we have two parallel plate capacitors here, and the area is capital A and charge is capital Q. Now we know that the electrostatic force F is given as Q square by 2A epsilon naught in this case. Okay, in the case of parallel plate capacitor. So we have to find the relation between force and what? And the distance between the plates. Okay. So in this formula, we cannot see the mention of any distance between the plates. Here obviously we can find the relation between force and charge. We can find the relation between force and area, but not distance. Okay. So we can say that the force is independent of distance. Independent of distance between the plates. So option A will be the correct answer. Now question number 5 is from the chapter Moving Charges and Magnetism, and the question is current sensitivity of a moving coil galvanometer is 5 division per milliampere and its voltage sensitivity, angular deflection per unit voltage applied, is 20 division per volt. Then the resistance of the galvanometer is, okay. So what is the formula for current sensitivity? The current sensitivity that is 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 equal to NBA by C. Okay, this is the formula for current sensitivity. And what is the formula for voltage sensitivity? That is Vs. It is equal to NBA divided by C into R. Okay, R is the resistance of the galvanometer. So I'm writing Rg. Okay, now we can see that NBA by C is equal to current sensitivity. So this voltage sensitivity is equal to current sensitivity divided by the resistance of the galvanometer. Now we have to find out the resistance. So resistance of the galvanometer Rg is equal to current sensitivity divided by voltage sensitivity. Now let's put the values. R is equal to current sensitivity divided by voltage sensitivity. That is 5 division per milliampere, right? 5 divided by the voltage sensitivity is 20 division per volt. So the current sensitivity was 5 division per milliampere, right? So 5 into 10 to the power 3 and the voltage sensitivity is 20 division per volt. So let's solve it. It will be 1 by 4 into 10 to the power 3. So it will be equal to 250 ohm. Okay, 1 by 4 is 0.25 and into 10 to the power 3 will be equal to 250. So 250 ohm, that is option D, will be the correct answer. Question number 6 is from the chapter Magnetism and Matter, and the question is a thin diamagnetic rod is placed vertically between the poles of an electromagnet. When the current in the electromagnet is switched on, then the diamagnetic rod is pushed up out of the horizontal magnetic field. Hence, the rod gains gravitational potential energy. The work required to do this comes from options are the current source, the magnetic field, then the induced electric field due to the changing magnetic field, and the last one is the lattice structure of the material of the rod. So here what can we understand from the question? We can understand that the energy from the current source is getting converted into gravitational potential energy. Okay, energy from the current source is getting converted into gravitational potential energy. So obviously energy and work are similar. So the source of work will also be the current source. So the work required to do this comes from the current source. So option A will be the correct answer. Now question number 7 is from the chapter Alternating Current, and the question is an inductor 20 millihenry, a capacitor 100 microfarad and a resistor 50 ohm are connected in series across a source of EMF V equals to 10 sine 314t. Okay, so this 10 is V naught. The power loss in the circuit is, so we have to find out the power loss. What is the formula for power loss? It is equal to Vrms by Z square into R. Okay, Z is the impedance. Now we neither know what is the value of Vrms nor we know the value of Z. So we have to find that. First we'll find the value of Vrms. So Vrms is equal to V naught divided by root 2. V naught is 10. It is mentioned in the question. So 10 divided by root 2. So 10 by root 2. This is Vrms. And what about the impedance Z? It is equal to under root R square plus omega L minus 1 by omega C whole square. Isn't it? So if we put the value, R is given as 50 ohm. So 50 square plus omega L is, omega is 314, right? It is given here 314, this is omega. 314, L is 20 millihenry. That is 20 divided by 1000, or 20 into 10 to the power minus 3 you can write. Minus 1 by omega c. So let's write it down here. 1 by omega, that is 314, into c is 100 microfarad. That is 100 into 10 to the power minus 6. And then we have to find out the square of this part. So on solving this, you'll get 56 ohm. Okay, so this is the value of impedance. Now we can put these values here. Vrms is equal to 10 by root 2. Z is equal to 56 ohm. T6 square of this into resistance, that is 50. Now when we solve this, we'll get 0.79. Therefore, option A will be the correct answer. It will be 0.79 watt. Okay, the unit of power is watt. So option A is the correct answer. Question number 8 is from the chapter Moving Charges and Magnetism, and the question is, a metallic rod of mass per unit length 0.5 kg per meter is lying on a smooth inclined plane which makes an angle of 30 degree with the horizontal. The rod is not allowed to slide down by flowing a current through it when a magnetic field of induction 0.25 Tesla is acting on it in the vertical direction. The current flowing in the rod to keep it stationary is. Okay. So what is being said in this question? See, we have an inclined plane. So let's draw the diagram for that. This is the inclined plane. Suppose the angle is 30 degrees. So this angle is 30 degree. Now here when the rod is kept at this point, suppose this is the point, here the rod is kept. Now the force in the downward direction will be mg sine theta, isn't it? So this force will be responsible for the rod to fall down the inclined plane. But according to the question, the rod is not allowed to fall down. And how is it done? By keeping the system in equilibrium or in balance condition by using a magnetic field B in the vertically upward direction. Okay, so this is the direction of the magnetic field. So what will be this horizontal force? This will be equal to B into I into L. Okay, and one of the component of this force will be parallel to the surface of the inclined plane, and it will be equal to F cos theta. Now, how the rod is kept stationary at this point? By balancing this mg sine theta, that is downward force, by the upward force F cos theta. Okay, so in equilibrium condition, this mg sine theta will be equal to F cos theta, and F is equal to BIL. So we can write that mg sine theta is equal to B into I into L cos theta. I is the current. Okay, we have to find out the current. The question is asked that the current flowing in the rod to keep it stationary is. So we have to find out the current I, that will be equal to mg sine theta divided by B into L into cos theta. Now mass per unit length is also given 0.5 kg per meter. So this mass per unit length, this thing is given here. Okay, so let's put the values. M by L is given as 0.5. So 0.5 into G is the acceleration due to gravity. Its value is 10 divided by B, that is magnetic field. So what is the value of B here? The magnetic field is 0.25 Tesla, isn't it? 0.25, and here we have sine theta by cos theta. So we can simply write tan theta, isn't it? So we can write tan, and theta is 30 degree. So here on solving this, we'll get 25 into 250. So 20 into tan 30 degree, that is 1 by root 3. So 20 divided by root 3, and on solving this, we'll get around 11.32. So this will be the value of the current flowing. So option C will be correct answer. 11.32 ampere is the right answer. Question number 9 is from the chapter Current Electricity, and the question is, a carbon resistor of 47 plus minus 4.7 kilo ohm is to be marked with rings of different colors for its identification. The color code sequence will be, okay. So what is given here? The resistance is given as 47 plus minus 4.7 kilo ohm. Now we can simplify this. 47 kilo ohm, that means 47 into 10 to the power 3 ohm, right? Plus minus 4.7 kilo ohm. Now we can write it in percentage. We know that 4.7 is the 10% of 47, right? Therefore, we can write plus minus 10%. 10% is the error. Now, we have to give it the color code. So for that, we have to remember a sequence of colors and the codes given to them. So you can simply recall an interesting sentence that BB Roy of Great Britain had a very good wife. Okay. Just to remember this sequence. So first B stands for black and its code is 0. The next B stands for brown, its code is 1. R is for red and the code is 2. O for orange and the code is 3. Y for yellow, code is 4. Then G for green and the code is 5. Next B is for blue and the code is 6. V for violet and the code is 7. G for grey, code is 8, and the W is for white and the code is 9. Okay. And one more thing we have to remember, that 5% error means it is for gold, 10% error means it is silver, and 20% error means no color. Okay. Now here we can see we have 47 into 10 to the power 3 plus minus 10%. So 4 is the code of which color? It is yellow. Okay. So the first one will be yellow. Then 7 is the code of which color? It is violet. Then yellow, after that violet. Then next is 10 to the power 3. Then we have to focus on 3. 3 is the code of orange, right? So orange. And the last one is 10% error. And we know the 10% error means silver. So it will be silver. So this will be the sequence: yellow, then violet, then orange, then silver. So which option will be correct? Option B will be the correct answer, right? Yellow, then violet, then orange, then silver. So option B is the correct answer. Now question number 10 is again from the chapter current electricity, and the question is: a set of n equal resistors of value R each are connected in series to a battery of EMF E and internal resistance R. The current drawn is I. Now n resistors are connected in parallel to the same battery. Then the current drawn from the battery becomes 10I. The value of n is, okay. So see, basically two conditions are mentioned in this question. In the first case, n number of equal resistors are connected in series, okay, and we know that in case of series combination, the net resistance is equal to n into R, where we have n numbers of equal resistors, okay. And in the second condition, they are connected in parallel, okay. N number of resistors, equal resistors are connected in parallel. So in case of parallel combination, net resistance is equal to R divided by n, right? You would be aware about this. So what will be the value of current in the first case? It will be equal to EMF divided by net resistance, right? And net resistance is equal to N into R. So this is the value of current in first case. So let's say this is equation 1. Then in the second case, the current is 10I. Okay. In this case, the current is 10I, and the equation for current will be EMF divided by net resistance. But in this case, net resistance is equal to R divided by N, right? R divided by N. But one thing we just left here, that the question also mentioned that it had the circuit had an internal resistance as well. Okay, here we have mentioned just the external resistances, so we'll just add the internal resistance to them. Okay, so in the first equation we'll have E divided by NR plus R. This R is internal resistance. Again in the second one also, E divided by R by N plus R. So R by N is the net resistance of the external resistances, and this R is internal resistance. So if we solve this, we'll get E divided by N r plus nr. Okay, so this n will go up and it will become E into n divided by r plus nr. So we'll say this is equation number 2. Now we have to find out the value of this n. So we can do this by dividing the equation 1 by 2, okay, or by dividing equation 2 by 1, okay, that will be better. So 2 by equation 1, we get, see, 10i divided by I equals to En by R plus NR into, here we'll get R plus NR divided by E. Okay, so E will be cancelled. Here R plus NR will be cancelled. So 10I by I will be equal to N and I will be cancelled. So we can see that N is equal to 10. Okay, here we get N equals to 10. Therefore, which option will be the correct one? Option A will be the correct answer. Question number 11 is again from the chapter Current Electricity, and the question is, a battery consists of a variable number n of identical cells having internal resistance R each, which are connected in series. The terminals of the battery are short circuited and the current I is measured. Which of the graphs shows the correct relationship between I and n? Okay, so what is given here? We have n number of resistors. Okay, so suppose this is EMF E, this battery has EMF E, and this is resistance R. Then again EMF E, then resistance R. So it will go up to number n, right? Now, what will be the voltage or the EMF across the cell? It will be equal to net EMF minus I into R net. Okay. Now, since they are connected in series, the resistance, the net resistance will be equal to N into R. Okay. And the net EMF will also be equal to N into E. Okay. So let's put this, E net is equal to N into E minus I, R net is equal to N into R. Okay. And since it is short circuited, so this voltage across the cell will become 0. Okay, so this complete thing will become 0. So we can write that N into E is equal to I into N into R. So N will be cancelled, so we can say that E is equal to I R. Now we have to find out the relation between I and N, right? So here we cannot see any relation between I and N. I will be equal to E by R, but no n is mentioned here, so I will be independent of n. That means if we draw a graph, this is n here, this is current I, then whatever is the value of n, I will not change, it will remain same. So something like this. So option A will be the correct answer. This will show the correct relation because I is independent of n. Question number 12 is from the chapter Wave Optics, and the question is, in Young's double slit experiment, the separation small d between the slits is 2 mm. The wavelength lambda of the light used is 5896 angstrom, and distance d, capital D, between the screen and the slits is 100 centimeter. It is found that the angular width of the fringes is 0.20 degree. To increase the fringe angular width to 0.21 degree, with same lambda and d, the separation between the slits needs to be changed too. Okay, so let's see what is said in the question. We have two slits, S1 and S2. Okay, these are two slits and the distance between the slits is small d, right? Now there is a screen, this is the screen, and the distance between the slits and the screen is capital D. This is also mentioned here, it is 100 centimeter. What else is mentioned? This small d is mentioned as 2 millimeter, right? 2 millimeter. Now, two conditions are given here. In the first condition, the angular width is 0.20 degree. We know that angular width is equal to lambda by small d. Okay. So, in this case, it is given as 0.20. So, 0.20 is equal to lambda by d. Suppose this is d1. Okay. So let's say this is equation 1. In the second condition, this angular width is changed to 0.21. Okay, 0.21. In this case, lambda will be same, okay, because it is mentioned that lambda and capital D will be same. So lambda will be same, but this small d will change, okay. The separation, the distance of separation will change. So this will be d2, and let's say this is equation 2. So we have to find out d2. d1 is given as 2 millimeter, okay. So let's divide equation 1 by 2. So on dividing equation 1 by equation 2, we can write 0.20 divided by 0.21 equals to lambda by d1, and d1 is given as 2 millimeter, okay. 2 millimeter into this one, lambda by d2 is there, so d2 by lambda, okay. So d2 by lambda, so lambda will be cancelled. Now we have to find out the d2, so let's write it here. d2 will be equal to this 0.20 divided by 0.21 into 2, okay. So we will get around 1.9 millimeter. Therefore option B will be the correct answer. Question number 13 is from the chapter Ray Optics and Optical Instruments, and the question is, an astronomical refracting telescope will have a large angular magnification and high angular resolution when it has an objective lens of, options are small focal length and large diameter, large focal length and small diameter, then small focal length and small diameter, and large focal length and large diameter, okay. So we have to consider two things, angular magnification and angular resolution, right? So for angular magnification, angular magnification, we know that the angular magnification of a refracting telescope is equal to FO by FE, okay. So O is the objective. So we can say that this angular magnification is proportional to the focal length of objective, okay. That means the objective should have a larger focal length, okay. Now second thing that we have to consider in this question is angular resolution. Angular resolution, so what is the formula for angular resolution? It is equal to capital D by 1.22 lambda, okay. D is the diameter, is the diameter. So this angular resolution is proportional to diameter. That means for a high angular resolution, diameter should be large, okay. So this objective focal length should also be large and diameter should also be large for um, large angular magnification and high angular resolution respectively. Therefore which option will be correct? Option D will be the correct one. Large focal length and large diameter are required. Question number 14 is from the chapter Wave Optics, and the question is, unpolarized light is incident from air on a plane surface of a material of refractive index mu at a particular angle of incidence I. It is found that the reflected and refracted rays are perpendicular to each other, okay. Which of the following options is correct for this situation? So let's see. We know that if this is the plane and a light is incident here at some point, then what will happen? Let's draw the normal here. This is the normal. One component of this ray will be refracted, okay. This is the refracted ray, okay, and this is known as partially polarized. This is known to be partially polarized, and the other component will be reflected from here, and this is known as plane polarized light. Plane polarized. Now in case these two components are perpendicular to each other as mentioned in the question, in this case also this plane polarized light and this partially polarized light are perpendicular to each other, then in this case what happens, the reflected one, the reflected light, that is the plane polarized light, is polarized with electric vector perpendicular to the plane of the incident, okay. Therefore option B will be the correct answer. That is why it is known as plane polarized light. Also we can remember one thing, that tan I is equal to mu in this case, and this is known as Brewster angle. Brewster angle. Question number 15 is from the chapter electromagnetic waves, and the question is, an electromagnetic wave is propagating in a medium with a velocity vector v equals to v I cap. The instantaneous oscillating electric field of this electromagnetic wave is along plus y. Then the direction of oscillating magnetic field of the electromagnetic wave will be along. Okay, so we know we have three directions. First one is x, then we have y, then we have z. Okay, all are perpendicular to each other. The x component are written as I cap, y component are written as j cap, and the z component are written as k cap. Okay, now we know that vector v is equal to vector e cross vector b. Okay, the cross product of electric field and field vector and magnetic field vector. So here it is given that vector v is equal to v I cap. V I cap, that means this is along the x direction, equals to electric field is along plus y. Okay, so this is E, y means j cap, right? So it will be j cap cross b. Now here we have to find out what component it will be. So we know that j cap cross k cap is equal to I cap. Okay, therefore this b should have k cap as the component. Okay, so it will be b k cap here, k cap, and k cap, that means z direction, and since we have plus y direction for the electric field, therefore magnetic field will also have plus, so it will be plus z direction. That means option B will be the correct answer. Now question number 16 is from the chapter Ray Optics and Optical Instruments, and the question is, the refractive index of the material of a prism is root 2 and the angle of the prism is 30 degree. One of the two refracting surfaces of the prism is made a mirror inwards by silver coating. A beam of monochromatic light entering the prism from the other face will retrace its path after reflection from the silvered surface if its angle of incidence on the prism is. Okay, so let's understand the question. Let's draw the prism here. Suppose this is the prism. Now if we take this surface as the surface where the where the light ray are incident, then this surface, the opposite one, will act as mirror. Okay, according to the question. So here it will be painted outside so that inside part will become the mirror. Now here let's draw the normal first. The light is incident here at this point. Okay, this is the incident ray. Now it will be refracted from here and reach this surface. Now since it is a mirror, it will come back from here. Okay, it will be reflected, and according to the question it retraces its path. Okay, in this case what happens, this angle becomes 90 degree. Okay, so this is 90 degree, and as mentioned in the question, the angle of the prism, that is this one, angle A is equal to 30 degree. So can we find out this part? Suppose this is angle x. We know that the sum of all the angles in a triangle are 180 degree. So we can say that 30 degree plus 90 degree plus x will be equal to 180 degree. So 120 degree plus x equals to 180 degree. Then x will be equal to 180 minus 120, that is 60 degree. Okay, so this will be 60 degree and this complete angle is 90 degree. Okay, because this is normal. So this part, only this part is the angle of refraction. So that means angle of refraction plus this angle x is equal to 90 degree. Angle of refraction will be equal to 90 degree minus x, that is 90 degree minus 60 degree. Okay, we have just calculated x, so it is equal to 30 degree. So now we have got the angle of refraction. We have to find out the angle of incidence. Okay, angle of incidence is asked. So we'll apply the Snell's law here. Snell's law. According to this, the refractive index of the air, that is 1 into sine I, will be equal to refractive index of the medium, that is root 2 into sine 30 degree. Okay, because we know that mu1 sine I is equal to mu2 sine R. Okay, R is the angle of refraction. So sine I will be equal to root 2 into sine 30 degree, that is 1 by 2. Sorry, it's 1 by 2. So this will be equal to 1 by root 2. Okay. Sine I is equal to 1 by root 2. That means I is equal to 45 degree. So option B will be the correct answer. Question number 17 is from the chapter Ray Optics and Optical Instruments, and the question is, an object is placed at a distance of 40 cm from a concave mirror of focal length 15 cm. If the object is displaced through a distance of 20 cm towards the mirror, the displacement of the image will be. Okay. So what is given here? Focal length of the mirror is given as 15 cm, and since it is a concave mirror, so focal length will be written in negative. So it will be minus 15 cm. Okay. And what else is given? The object distance from the mirror is given as 40 cm. Again, it will be minus 40 cm since it is a concave mirror. Okay. Like this. So this is the mirror. Here we have kept the object and this distance is 40 cm. Now, we know the mirror formula, that 1 by f equals to 1 by u plus 1 by v, right? So using this, we can find out the value of v, that is the image distance from the mirror. So let's put the values. 1 by minus 15, or we can simply write minus 1 by 15 equals to 1 by minus 40, u is 40, right? So it will be minus 1 by 40 plus 1 by v. So 1 by v will be equal to minus 1 by 15 plus 1 by 40. LCM will be 120. Here we have minus 8 plus 3. So on solving this, we get minus 5 by 120. Let's simplify this. Here we get minus 1 by 24. So 1 by v is equal to minus 1 by 24. That means v is equal to minus 24. Okay. That means 24 centimeter from the mirror. Now, let's come to the second condition. Condition 2. Here it is said that the object is displaced through a distance of 20 centimeter. Okay. So the object distance will be what? 40 minus 20, that is 20 centimeter. Okay. So this time the object distance is 20 centimeter. Focal length will remain same, that is 15. Okay. And both will be in minus. So minus 20 centimeter is the object distance and focal length is minus 15 centimeter. Again, we can find out the image distance using the same formula, that is 1 by f equals to 1 by u plus 1 by v. So minus 1 by 15 equals to minus 1 by 20 plus 1 by v. So 1 by v will be equal to minus 1 by 15 plus 1 by 20. So let's solve this. 1 by v will be equal to 60 minus 4 plus 3. So it will be minus 1 by 60. That means v is equal to minus 60. Okay. So we can see, let's write v dash here just to differentiate it from the earlier case. So earlier the image distance was 24 centimeter from the mirror, and this time the image distance is 60 centimeter from the mirror. So what will be the shift? The shift in the image size, image distance will be equal to final distance minus the initial one. Okay. So v dash minus v. V dash is 60 centimeter minus, earlier it was 24 centimeter. So it will be 36 centimeter. So 36 centimeter will be the answer. Here in the options we can see two options have 36 centimeter. One is away from the mirror, second is towards the mirror. So we can see that earlier it was 24 centimeter and then later it shifted from 24 to 60. That means the distance increased. Therefore we can say that it moved away from the mirror. Okay, therefore option B will be the correct answer. Now question number 18 is from the chapter electromagnetic induction, and the question is the magnetic potential energy stored in a certain inductor is 25 millijoule. That means 25 into 10 to the power minus 3 joule. When the current in the inductor is 60 milliampere, that is 60 into 10 to the power minus 3 ampere. Okay. This inductor is of inductance. So inductance is asked, that means L is asked. Okay. So we know the formula that the magnetic potential energy U is equal to half L I square. Okay. Where L is the inductance. It is inductance. I is the current and U is the potential energy. Okay. Magnetic potential energy. Now, potential energy is given here. It is 25 millijoules. So that means 25 into 10 to the power minus 3 equals to half. L is inductance that we have to find out. Current is 60 into 10 to the power minus 3 ampere, and we have to find out the square of current, okay, according to the formula. So let's solve this. L will be equal to 25 into 10 to the power minus 3 into 2 divided by the square of current will be 3600 into 10 to the power minus 6. Okay. So on solving this, what do we get? We'll get 500 divided by 36. So finally we'll get 13.89 and the unit of inductance is Henry. So option C will be the correct answer. Now question number 19 is from the chapter nuclei, and the question is for a radioactive material half-life is 10 minutes. If initially there are 600 number of nuclei, then the time taken in minutes for the disintegration of 450 nuclei is, okay. So what is given here? Half-life is given, T half is 10 minutes. Then initial number of nuclei are given. This is N naught, it is 600. So what will be the number of nuclei after disintegration? The number of nuclei after disintegration, that is N, will be equal to initial number N naught minus the number of disintegrated nuclei. Okay. Disintegrated nuclei. So initial number was 600. Number of nuclei disintegrated is 450. So how many left? 150. Okay. So this is the number of nuclei at time t. Now we have a formula n by n naught equals to half to the power t divided by t half. Okay. So this t is time taken. This is time taken. And this is half-life. T half is half-life. So let's put the values here. N is equal to 150. N naught is 600 equals to half to the power time taken divided by half-life. Now on solving the left hand side we get 1 by 4. So 1 by 4 can be written as half to the power 2 or half square. Okay. And this side we have half to the power t by t half. So the base is same, that is half. So we can just compare the powers. So 2 equals to time taken divided by half-life. So the time taken will be equal to 2 into half-life, and half-life is 10 minutes. So 2 into 10 will be equal to 20 minutes. Therefore 20 minutes will be answer. That is option A will be the correct answer. Now question number 20 is from the chapter atoms, and the question is the ratio of kinetic energy to the total energy of an electron in a Bohr's orbit of hydrogen atom is. Okay. Options are 1 is to 1, 1 is to minus 1, 1 is to minus 2 and 2 is to minus 1. Okay. So for that we simply have to remember the relation between kinetic energy and total energy. Kinetic energy just the negative of total energy. Okay. This is the relation between these two. That means if kinetic energy is 1, then total energy will be minus 1. Okay. And if kinetic energy is minus 1, then total energy will be 1. Therefore, option B will be the correct answer. Okay. Now question number 21 is again from the chapter atoms, and the question is an electron of mass m with an initial velocity vector v equals to v naught I cap, where v naught is positive enter an electric field vector E equals to minus E naught I cap, where E naught is constant and positive at t equals to 0. If lambda naught is its de Broglie wavelength initially, then its de Broglie wavelength at time t is. Okay. So initial wavelength is given and we have to find out the wavelength at time t. Now if we look at the options, we can see that all the answers are in terms of initial de Broglie wavelength lambda naught. Okay. So what will be lambda naught? We know that wavelength is equal to h by mv. So it will be h by mv naught. Okay. So at last we have to find the answer in the terms of lambda naught. Now initial velocity is given. Initial velocity of the electron is given as v naught I cap. Can we find out the force on the electron? Force is equal to charge into electric field, right? So charge on the electron is minus E and the electric field is given as minus E naught I cap. So here we'll get minus minus plus, that is E naught I cap. Okay. Now this is the force. What will be the acceleration? Acceleration will be equal to force by mass, right? So force is E naught I cap and divided by mass. So this is the acceleration of the electron. Now we know that we have the formula V equals to U plus AT. So we can find out the velocity of the electron. Initial velocity, that is U, is given as V naught I cap, right? So it will be V naught plus, here we have A is E into E naught by M and T. Okay, we'll take the I cap outside the bracket. So now we have to find out the wavelength, lambda dash, okay, de Broglie wavelength at time t. So that will be equal to h by m into final velocity. So in place of final velocity, we'll put this thing that we have just calculated. So it will be equal to h by m into v naught plus e naught by m t. Okay. So if we take the v naught outside the bracket, it will be h by mv naught, and here we have 1 plus e naught by m v naught here into t. Okay. Now we have to find out the answer in terms of lambda naught. So we know that h by mv naught is equal to lambda naught. So this part is equal to lambda naught. Okay. So in place of this, we can put lambda naught divided by, here we'll get 1 plus e naught t divided by m v naught. Okay. So which of the answers will be correct? Option A will be the correct answer. Okay. Now question number 22 is from the chapter Dual Nature of Radiation and Matter. And the question is, when the light of frequency 2 nu naught, where nu naught is threshold frequency, is incident on a metal plate, the maximum velocity of electrons emitted is V1. When the frequency of the incident radiation is increased to 5 nu naught, then the maximum velocity of electrons emitted from the same plate is V2. Then the ratio V1 to V2 is, okay. So here we have two cases. In the first case, that is case 1, the frequency is given as 2 nu naught. Okay. So what will be the maximum kinetic energy in this case? We know that maximum kinetic energy equals to h nu minus h nu naught. Okay. So in this case, nu is given as 2 nu naught. So we can put 2 nu naught in place of nu minus h nu naught, that is 2h nu naught minus h nu naught. So it will be equal to h nu naught. Okay. So this is the maximum kinetic energy in the first case. That means half m v1 square equals to h nu naught. Okay. Because in this case the velocity is v1, right? Now we come to the second case, case 2. In this case, the frequency is given as 5 nu naught. Okay. So what will be the maximum kinetic energy? Ke max, that is equal to half m v2 square will be equal to h nu minus h nu naught. Nu is 5 nu naught, right? So let's put it here, 5 nu naught minus h nu naught. So 5 h nu naught minus h nu naught will be equal to 4 h nu naught. Okay. So in this case, the maximum kinetic energy, that is half m v2 square is equal to 4 h nu naught. Now we have to find out the ratio of speeds, that is v1 by v2. Okay. So we can do this by finding the ratio of kinetic energies. Kinetic energy 1 by kinetic energy 2. We are talking about the maximum kinetic energies. So it will be equal to half m v1 square by half m v2 square, and that will be equal to h nu naught. In first case it is h nu naught divided by 4 h nu naught. Okay, so nu naught cancelled, h cancelled, it will be 1 by 4. And this side also half cancelled, mass cancelled. So we can say that v1 by v2 square is equal to 1 by 4. But we have to find out the ratio v1 by v2. So v1 by v2 will be equal to root of this 1 by 4. So that will be equal to 1 by 2. Therefore, the ratio will be 1:2. Okay. So out of the given options, option A will be the correct answer. Now question number 23 is from the chapter Semiconductor Electronics, and the question is, in the combination of the following gates, the output Y can be written in terms of inputs A and B as. Okay. So here we can see we have two NOT gates, NOT gate 1 and NOT gate 2. Okay. Upper and lower one. Then we have two AND gates. This is the first AND gate and this is the second AND gate. Okay. And at last we have an OR gate. Now, if you remember, for AND gate, we put a dot. Okay, we put a dot between the inputs. And in case of OR gate, we put a plus sign between the inputs. Okay, so between the outputs. Now, we have two inputs here, input A and input B. Let's see where is this input A going. First, it is going in this direction towards the upper AND gate. So here, one of the inputs received is A. Okay, by this AND gate. And then A also moves downward in this direction and it moves towards the lower NOT gate and comes as input in the lower AND gate. Okay, so here since it passes through NOT gate, so it will become A bar. So one of the inputs for the second AND gate is A bar. Now if we talk about the input B, first it moves in the straight direction, passes through this upper NOT gate and comes as B bar. Okay, and another B moves downward, comes towards the lower AND gate and comes as B. Okay, so we can see that the input received by the upper AND gate is A and B bar. Okay, so it will become what? A dot B bar. Okay, and the inputs received by the lower AND gate are A bar and B, so it will become A bar dot B. Now these two will act as inputs for this OR gate, so it will become A dot B bar plus A bar dot B, because for OR gate we put a plus sign. So out of the given options, option B will be the correct answer. Now question number 24 is again from the chapter Semiconductor Electronics, and the question is, in the circuit shown in the figure, the input voltage V1 is 20 volts, V across B, that is voltage across B, is 0 and voltage across C is also 0. The values of IB, IC and beta are given by. Okay, so the voltage across B is 0, that means this voltage is 0. Voltage across C is also 0, so this is also 0. Now what will be the voltage across BC? Since it is a common base, so it will be the we know that in common base, here we have emitter, here we have collector. Okay, so the voltage across this complete CE will be the sum of voltage across BE and BC. Okay, voltage across BE and voltage across BC or CB. So here CE is already given, it is 0. Voltage across BE is also given as 0. So what will be the voltage across CB? It will also be 0. Okay, so this will also be 0. Now here we have to find out three things: IB and IC and beta. So first we have to find out the IB. Now we'll use the method, we'll start from this VI. Okay, now focus on the direction of arrows, we'll move this side, then BE and then move downwards. At last it is grounded, So here the potential will be, or the voltage will be V0, and that will be 0 because it is grounded. Okay, V0 is the final potential. So here let's write down the formula. That is VI minus IB RB minus voltage across B minus equals to the final voltage, that is 0. Okay, so let's put the values here. VI is given as 20 volt in the question, minus IB is unknown, we have to find out. The resistance across B is 500 kilo ohm. Okay, so 500 into 10 to the power 3 ohm minus voltage across B is 0 and the final voltage is also 0. So let's simplify. 20 equals to 500 into 10 to the power 3 IB. Okay, we have taken this complete part on the right hand side. Now we have to find out the IB. So IB will be equal to 20 divided by 500 into 10 to the power minus 3. Okay, so 10 to the power 3 will move up as 10 to the power minus 3. So on solving this, what do we get? 2 by 50, that means 1 by 25. So 1 by 25 into 10 to the power minus 3. 1 by 25 is equal to 0.04 into 10 to the power minus 3. Since the answers are given in microampere, so we can write it as 40 into 10 to the power minus 6 ampere. That is equal to 40 microampere. Okay. So the IB is 40 microampere. So either option A or option C can be the correct answer. Now let's check for IC. In the second case, we have to find out the IC. We'll use the same method. So this time 20 minus IC into the resistance is 4 kilo ohm, right? So 4 into 10 to the power 3 ohm minus that potential is also 0 and the final potential is also 0. Okay. So 20 equals to 4 into 10 to the power 3 IC. Then IC will be equal to what? It will be 20 divided by 4 and 10 to the power 3 will move up as 10 to the power minus 3. So it is 5 into 10 to the power minus 3 ampere. That is 5 milliampere. Sorry, it is milliampere, right? Not microampere. So milliampere. So we can see that the IB is 40 microampere and IC is 5 milliampere. So in option C, we have IC as 5 milliampere. Therefore, this will be the correct answer. But still, we can confirm by finding the value of beta. So what is the formula to find out the beta? Beta is equal to IC divided by IB. Now we know the values of these both. IC is 5 milliampere. That is 5 into 10 to the power minus 3 ampere. And IB is 40 microampere. That is 40 into 10 to the power minus 6. Okay. So 5 into 8 is 40. So 1 by 8 into 10 to the power minus 3 plus 6, that is 1 by 8 into 10 to the power 3. Now on solving this, we'll get 125. Okay. So option C is confirmed to be the correct answer here. Now this question is again from the same chapter, Semiconductor Electronics, and the question is, in a PN junction diode, change in temperature due to heating, option A affects only reverse resistance, option B affects only forward resistance, option C affects the overall VI characteristics of the PN junction, and the last one is does not affect resistance of PN junction. Okay, so the correct answer will be option C. Okay, it will affect the overall VI characteristics of PN junction. What is the reason? See, the reason is that due to heating, the number of electron hole pairs will increase. Okay, let's write it down here. Due to heating, number of electron hole pairs will increase, and due to this, the overall resistance of the diode will change. Okay, so due to this, the overall resistance of diode will change. And because of this reason, the forward biasing as well as reverse biasing both are changed. Okay, forward as well as reverse biasing will change. Therefore, we say that it will affect the overall VI characteristics of the PN junction. Now, question number 26 is from the chapter Systems of Particles and Rotational Motion. And the question is, a solid sphere is rotating freely about its symmetry axis in free space. The radius of the sphere is increased, keeping its mass same. Which of the following physical quantities would remain constant for the sphere? Options are angular velocity, moment of inertia, angular momentum, and rotational kinetic energy. So we know that torque is equal to dl by dt. Okay, that means the rate of change of this angular momentum. L is angular momentum. Now in this case we can see that the sphere is rotating freely, that is no torque is being applied. Okay, no external torque is being applied. So external torque is 0, that means dl by dt is also 0. So we can say that L is constant and L is angular momentum. Okay. Therefore, option C will be the correct answer. Angular momentum will remain constant for the sphere. Question number 27 is from the chapter Gravitation. And the question is, the kinetic energies for a planet in an elliptical orbit about the Sun at positions A, B and C are Ka, Kb and Kc respectively. AC is the major axis and SB is perpendicular to AC at the position of the Sun S as shown in the figure. Then we have to find out the correct option. Okay, the relation between Ka, Kb and Kc. Now look at this figure. We can see that S is the point where Sun is located, and in the orbit shown here the planet is moving. Okay, so from here we can see that A is the perihelion point. Perihelion, that means it is the closest point. At this point the distance between this A and the planet will be least, and C is the aphelion. So this is the farthest point from the planet. Now we know that closer the point or closer the distance, faster will be the movement of the earth. Okay, that means more will be the speed, or velocity. So we can see that the minimum distance is for point A, then point B and then point C. Okay, this is the sequence of distance. Therefore, what will be the sequence of velocity? It will be maximum for A, then minimum for C. Okay, and same will be for kinetic energy also. So K maximum, then Kb and then Kc, because kinetic energy is equal to half mv square. So kinetic energy is proportional to v square. Okay, therefore this will be the sequence for kinetic energies. So which option will be the correct one? Option number B will be the correct answer. Now question number 28 is again from the same chapter, Gravitation, and the question is, if mass of the Sun were 10 times smaller and the universal gravitational constant were 10 times larger in magnitude, which of the following is not correct? Okay, so let's see what is the formula for the acceleration due to gravity. Small g is equal to capital G, that is gravitational constant, into mass of the earth divided by radius of the earth square. Okay, so we can see that the acceleration due to gravity depends upon the gravitational constant. Okay, also it depends upon the mass of the earth, not the mass of the sun. So if mass of the sun were 10 times, it will not affect g, but in the second case that universal gravitational constant is also 10 times. So in this case, if g dash becomes 10g, then obviously small g will also increase. Okay, so small g will increase because it depends upon the gravitational constant. So we can see the options. In the first option, it is given that raindrops will fall faster. This is correct because if small g will increase, then obviously acceleration due to gravity that will increase, then the raindrops will fall faster. Okay, because acceleration is more. So this is a correct statement. This is a correct statement. Second is walking on the ground would become more difficult. Obviously, when acceleration due to gravity will increase, we will not be able to walk properly. So this is also a correct statement. Then the third one is small g on the earth will not change. This is not true because we have seen that small g will increase. Okay, it is directly proportional to capital G. So this is the incorrect statement that is asked in the question. Let's see the last one. It is the time period of a simple pendulum on the earth would decrease. So what is the time period formula? It is 2 pi root under L by G. Okay. So T is inversely proportional to root G. So obviously when G increases, time period will decrease. So this is also a correct statement. So only incorrect statement is option C. Therefore this will be the correct answer. Question number 29 is from the chapter Kinetic Theory, and the question is a solid sphere is in rolling motion. In rolling motion, the body possesses translational kinetic energy as well as rotational kinetic energy simultaneously. Then the ratio kT is to kT plus kr for the sphere is. Okay. So kT is the translational kinetic energy. So translational kinetic energy, that is kT, will be equal to what? Half mv square. Simple. But in case of rotation, rotational kinetic energy will possess the translational one as well as rolling one. Okay. According to this question also, it is also mentioned in the question, right? Translational is half mv square and rotational is half I omega square. Okay. Now, what will be the value of I for a solid sphere? Let's write it down here. For a solid sphere, I is equal to 2 by 5 mr square. Okay, mr square. So we'll put this value here. This is half mv square plus half, in place of I will write 2 by 5 mr square. Okay, and what will be the value of omega? Omega is equal to v by r. Okay, so we'll write v by r square. So let's solve this. Half mv square this side plus this side, 2 will be cancelled. So it will be 1 by 5. 1 r will also, okay, this is r square. So r square will be cancelled. So it will be mv square. So half mv square plus 1 by 5 mv square. So here we'll get 10 and 5 plus 2, that is 7. 7 by 10 mv square. Okay. So translational is half mv square and rotational is 7 by 10 mv square. Okay, for a solid sphere. Now we have to find the ratio of these two. So translational by rolling, that is kT plus kr. So it will be equal to half mv square divided by 7 by 10 mv square. So v square cancelled, cancelled. So it will be half into 10 by 7. That means 5 by 7. Okay, 5 by 7. So the ratio will be 5:7. Therefore, which option will be correct? Option B will be the correct answer. Question number 30 is from the chapter Mechanical Properties of Fluids, and the question is a small sphere of radius r falls from rest in a viscous liquid. As a result, heat is produced due to viscous force. The rate of production of heat when sphere attains its terminal velocity is proportional to. Options are r cube, r square, r to the power 4 and r to the power 5. So basically we have to find the relation between the rate of production of heat and the radius. Okay, so rate of production of heat means what? Rate of production of heat, that can be related to the rate of work done, right? And that will be equal to power. Okay, so we have to find out the relation between power and radius. So what is the formula for power? Power is equal to force into velocity, and in this case it will be terminal velocity, right? So power is equal to force into terminal velocity. What is the formula for viscous force? This force is nothing but the viscous force. So the formula for viscous force is 6 pi eta r and terminal velocity. Okay, Vt is terminal velocity into terminal velocity, that is Vt again. So it will be equal to 6 pi eta r Vt square. So this is the formula of power. Now, what is the formula for terminal velocity Vt? It is equal to 2 by 9 r square rho minus sigma into g divided by eta. Okay, so here in this formula we have Vt square. So Vt square will be 4 by 81 into r to the power 4 rho minus sigma square g square divided by eta square. Okay, so let's put this value in this formula. So power will be equal to 6 pi eta r and Vt square, that means this square. Okay, so square of Vt is 4 by 81 into r to the power 4 rho minus sigma square g square divided by eta square. Now, can we find out the relation between this power and the radius? So one radius is this side and 4 power of radius on this side. So the total will be 4 plus 1, that means 5. So power will be proportional to r to the power 5. Okay. Therefore, which option will be correct? Option D will be the correct answer. Now question number 31 is from the chapter thermodynamics, and the question is a sample of 0.1 grams of water at 100 degrees Celsius and normal pressure, that is 1.013 into 10 to the power 5 Newton per meter square, requires 54 calorie of heat energy to convert to steam at 100 degrees Celsius. If the volume of the steam produced is 167.1 cc, the change in internal energy of the sample is. So we have to find out the value of delta U, right? Now we'll use the formula delta Q equals to delta U plus delta W. Okay, so for that we should know the value of delta Q as well as delta W. So let's see. Delta Q is already mentioned here. It is equal to 54 calorie. Okay, it is mentioned in the question. So we'll convert it into joule. It will be 54 into 4.18 joule. That means 225.72 joule. Okay, so this is an important data that we have to remember. Then we have to find out the delta W. So we know that this is equal to P delta V. P is given in the question, delta V is also given. P is given as 1.013 into 10 to the power 5. So 1.013 into 10 to the power 5 Newton per meter square into delta V, that is 167.1 cc. 167.1 cc. Okay, cc means what? Cubic centimeter. So 1 centimeter equals to how many meter? It will be 10 to the power minus 2 meter, right? And cubic centimeter means cube of this. So 10 to the power minus 6 meter. So we'll write 167.1 into 10 to the power minus 6 meter. So on multiplying 1.013 and 167.1, we get 169.27, and 10 to the power 5 into 10 to the power minus 6 will be 10 to the power minus 1. So the final will be 16.927 joule. So this is the value of P delta V. Now we'll use the final formula, that is delta Q equals to delta U plus delta W. So delta U will be equal to delta Q minus delta W, and delta W is nothing but P delta V. So delta Q minus P delta V. So let's put the values. Delta Q was 225.72 joule and P delta V was this one, 16.927 208.927 joule. On subtracting this, what do we get? We'll get 208.7 joule. So the correct answer will be option number B. Now question number 32 is from the chapter Mechanical Properties of Solids, and the question is, two wires are made of the same material and have the same volume. The first wire has cross-sectional area A and the second wire has cross-sectional area 3A. If the length of the first wire is increased by delta L on applying a force F, how much force is needed to stretch the second wire by the same amount? Okay. So here it is given that they have the same volume. Okay, volume is same. So it says that V1 is equal to V2. Okay, and volume is equal to area into length. So A1 into L1 is equal to A2 into L2. Also it is given that area of the second one is 3 times the area of the first one. Okay, it is 3A. So A1 into L1 is equal to 3A1. Okay, A2 is equal to 3 times A1 into L2. So A1 cancelled. L1 equals to 3L2. So from here we can say that L2, that is the length of the second wire, is 1/3 the length of first wire. Okay, so this is the relation between the lengths of these two wires. Now it is also given that they have the same material. They are made up of same material. That means in both the wires the Young's modulus will remain same. Young's modulus will be same. So Young's modulus is equal to F into L divided by A into delta L. Okay. So in this case we can write that F1 into L1 divided by A1 into delta L1 equals to F2 into L2 divided by A2 into delta L2. Again it is given that the second wire is stretched by the same amount in the last sentence. So we can say that delta L1 is equal to delta L2. So these two will be cancelled. Now we can put the values of L2 and A2 as compared to L1 and A1. So F1 into L1 divided by A1 this side, and this side F2 into L2. So in place of L2 we can write 1/3 of L1, right? L1 by 3 divided by A2. So A2 is 3 times A1. Now A1 cancelled. L1 also cancelled. So we can say that F1 is equal to F2 divided by 9. Okay, this 3 and this 3, 9. So what is asked here? It is asked how much force is needed to stretch the second wire. That means F2 is asked. So F2 will be 9 times F1. Okay. So 9 times the initial force applied on the first wire. So option A will be the correct answer. Now question number 33 is from the chapter Thermal Properties of Matter, and the question is, the power radiated by a black body is P and it radiates maximum energy at wavelength lambda naught. If the temperature of the black body is now changed so that it radiates maximum energy at wavelength 3 by 4 times lambda naught, then the power radiated by it becomes n times the initial power. The value of n is, okay. So let's apply the Vane's law here. So according to the Vane's law, the product of lambda max and temperature remains constant. Okay, lambda max is the wavelength at which the maximum energy is radiated. Okay, so lambda max 1 into T1 will be equal to lambda max 2 into T2. Okay, also it is mentioned here that initially lambda max was lambda naught. So lambda naught into T1 will be equal to, after that it becomes 3 by 4 times lambda naught, right? So 3 by 4 times lambda naught into T2. So lambda naught cancel. We can say that T2 by T1 is equal to 4 by 3, right? So let's note this. Now we'll use another law, that is Stephen-Boltzmann law. So according to the Stephen-Boltzmann law, the power radiated is given by the formula A into E into sigma T to the power 4. So E here stands for emissivity. Sigma is the constant, Stephen-Boltzmann constant, and T is temperature. Okay. So basically we have to focus on the temperature. So power is proportional to fourth power of temperature. Okay. So if we have to compare the power P2 by P1, it will be T2 by T1 to the power 4. Sorry, this is 4. Okay. Now, it is given that if initial power, that is P1, was P, then the power after the temperature is changed, that is P2, becomes N times P, right? So in place of P2 we can write NP. So N times P divided by P will be equal to T2 by T1, that is equal to 4 by 3. 4 by 3 to the power 4. So P cancels. So what will be the value of N? N will be equal to 4 by 3 to the power 4, that is 256 divided by 81. Okay. So option D will be the correct answer. Question number 34 is from the chapter Kinetic Theory of Gas, and the question is, at what temperature will the RMS speed of oxygen molecules become just sufficient for escaping from the Earth's atmosphere? It is given that mass of oxygen molecule is this and Boltzmann constant is also given. Okay. So basically we have to find the temperature at which the RMS speed of oxygen becomes equal to the escaping velocity, right? So in this case, Vrms should become equal to the escape velocity. Now, what is the escape velocity? Escape velocity is equal to 11.2 kilometer per second. Okay. And that is equal to 11200 meter per second. Okay. We have to use this one. Okay. In meter per second. So Vrms is what its formula is, under root 3 kT divided by m. M is the mass, T is the temperature, and K is Boltzmann constant. So that should be equal to escape velocity, that is equal to 11200 meter per second. Okay. So we can write that 3 kT by m will be equal to square of this. Okay. Now temperature is to be calculated. So temperature will be equal to square of this into mass divided by 3 into K. Okay. So let's put the values here. The square of 11200 will be equal to 12544 into 10 to the power 4 into mass is given as 2.76. 2.76 into 10 to the power minus 26 kg divided by 3 into K. So the value of K is also mentioned in the question. It is 1.38 into 10 to the power minus 23 joule per Kelvin. Now you have to solve this, and on solving you will get the answer 8.36 into 10 to the power 4 Kelvin. Okay. So this is a lengthy calculation, but you have to calculate. So option B will be the correct answer. Question number 35 is from the chapter Thermodynamics, and the question is, the volume of a monoatomic gas varies with its temperature T as shown in the graph. Now the ratio of work done by the gas to the heat absorbed by it when it undergoes a change from state A to state B is. Okay. So let's have a look at this graph. We can see that this is the VT graph, and VT graph gives us the pressure. And as it is clear from this graph, the pressure is constant in this case. So this is an isobaric curve. Okay. It is an isobaric graph. That is, pressure is constant. Now what is asked in this question? The ratio of work done to the heat absorbed, that is delta W by delta Q is asked, right? And we know that delta W is equal to P delta V, and delta Q for an isobaric process will be equal to N Cp delta T. Cp is specific heat at constant pressure. Okay. N is the number of moles. So delta W by delta Q will be equal to P delta V divided by N Cp delta T. Also we know that PV equals to nRT. So P delta V will be equal to nR delta T. Okay. So in place of P delta V we can write nR delta T. R is the gas constant, N is the number of moles of gas, and delta T is the temperature. divided by N Cp delta T. Delta T is on both sides, so cancelled. N cancelled. So what is left here? R by Cp. Okay. So delta W by delta Q is equal to R by Cp. Now, we also know that for a monoatomic gas, as it is mentioned that the gas is monoatomic, so for monoatomic gas, Cp is equal to 5 by 2R. So in place of Cp, we can write 5 by 2R, R divided by 5 by 2, that means 5 here and 2 will go up, okay, R. So it is equal to 2 by 5. So delta W by delta Q, so this ratio is equal to 2 by 5. Therefore, option A will be the correct answer. Question number 36 is from the chapter Waves, and the question is the fundamental frequency in an open organ pipe is equal to the third harmonic of a closed organ pipe. Okay, it is organ. If the length of the closed organ pipe is 20 centimeter, then the length of the open organ pipe is, okay. So let the length of the closed organ pipe be L1. Okay, so L1 is given as 20 centimeter. And we have to find out the length of the open organ pipe. So let's take it as L2 and we have to find it out. Okay. Now, we know that for a closed organ pipe, the third harmonic frequency is equal to 3V by 4L. Okay, 4. And what is the length for closed organ pipe? It is taken as L1. Okay, we have taken it as L1. Also, for an open organ pipe, the fundamental frequency is equal to V by 2L. So we have taken the length as L2. Okay, so 2L2. Now it is given that both of them are equal. So according to the question, 3V by 4L1 is equal to V by 2L2. Okay, so V cancelled and L2 will be equal to 4L1 divided by 3 into 2. Okay, so 2 into 2 is 4. And also we know that L1 is given as 20 centimeter. So 2 into L1, that is 2 into 20 divided by 3. Okay, centimeter. So on solving this, we'll get 40 by 3 centimeter, that is 13.33 centimeter, and the closest option is option A, 13.2 centimeter. Therefore it will be the answer. Question number 37 is from the chapter Thermodynamics, and the question is the efficiency of an ideal heat engine working between the freezing point and boiling point of water is. Okay, so what is the formula for efficiency? Efficiency of an ideal heat engine is given by the formula 1 minus T2 by T1. Okay, what is T2? T2 is the sink temperature, and T1 is the source temperature. Okay. Now, sink temperature will be nothing but the freezing point of water according to this question, right? Freezing point, that is equal to 273 Kelvin, right? And T1, that is the source temperature, will be the boiling point of water, that is equal to 373 Kelvin. Now, let's put the values in the formula for efficiency. It is equal to 1 minus T2 by T1, that is 273 Kelvin divided by 373 Kelvin. On solving this, we get the LCM will be 373. Here we get 373 minus 273. So that is equal to 100 divided by 373. Okay. Okay, if you divide it, it will get the value 0.268. Now, all the options are given in percentage, so we have to find out the percentage of efficiency. So we'll just multiply this value by 100. So here we'll get 26.8%. That means option A will be the correct answer. Now question number 38 is related to work energy and power as well as circular motion. And the question is, a body initially at rest and sliding along a frictionless track from a height h as shown in the figure just completes a vertical circle of diameter AB equals to d. The height h is equal to, okay. So the body is released from rest at this point, okay, from the top point. Then it reaches the bottom and just completes a vertical circle. So since the track is frictionless, therefore we can say that the total mechanical energy will be conserved. Okay, total mechanical energy will remain conserved. So we can say that the initial total mechanical energy will be equal to final total mechanical energy, right? And the total mechanical energy is the sum of kinetic energy and potential energy. So kinetic energy 1 plus potential energy 1 will be equal to kinetic energy 2 plus potential energy 2. Okay. Now, initially the body was at rest, therefore the initial kinetic energy will be 0 and the initial potential energy will be mgh, okay, at the top point. And then at last the final kinetic energy will be half mv square, but the final potential energy will be 0. Okay. So this will be 0. So here we can say that mgh is equal to half mv square. Cancelled. So gh is equal to half v square. So can we say that h is equal to what? V square by 2g, right? Now, we know that for completing the vertical circle, completing the vertical circle, the minimum velocity should be equal to under root 5gr. Okay, that means this velocity that we have used in this formula should be equal to 5gr. Okay, so h should be equal to v square is there, therefore it will be 5gr. Okay, divided by 2g, and g cancelled, so it is equal to 5 by 2 r, and we know that r is the radius which is half of diameter. So in place of radius we can write half of diameter. Also diameter is given here, so 5 by 4 d. Okay, diameter is given as d only, so it will be 5 by 4 d only. Okay, this will be the value of height, therefore option C is the correct answer. Now this question is from the rotational motion, and the question is, three objects, A is a solid sphere, B is a thin circular disc, and C is a circular ring, each having the same mass m and radius r. They all spin with the same angular speed omega about their own symmetry axis. The amounts of work required to bring them to rest would satisfy the relation. Okay. So we know that we have to apply some work, we have to do some work in order to bring them to rest. So we have to compare the work done in these three cases, in case of solid sphere, in case of thin circular disc, and in case of circular ring. Okay. So we know that work done is equal to change in kinetic energy. So delta W will be equal to delta K. Okay. And change in kinetic energy is equal to half I omega square in case of rotational motion, right? So work done will be equal to half I omega square. Now it is given that the angular speed is same. Omega is same for all. That means the work done will be proportional to I. Okay. I is the moment of inertia. I is the moment of inertia. Now it depends what is the moment of inertia of these three objects. Okay. So for solid sphere is what? It is equal to 2 by 5 mr square. Then let's say this is I1, then I2, that is the moment of inertia for thin circular disc is equal to half mr square, and I3, that is the moment of inertia of a circular ring is equal to mr square. Okay, so we have to compare these moment of inertias, right? So work done, that is WA is to WB is to WC. If we have to find the ratio, will be equal to I1 is to I2 is to I3. Okay, so that will be equal to 2 by 5 is to 1 by 2 is to 1. Okay, because mr square is same. Now we can simplify this by finding the LCM. So the LCM of 5, 2 and 1 will be 10. So here we will get 5 into 2 is 10. So 2 into 2 is 4. Then 2 into 5 is 10. Then 1 into 5 is 5. And here 1 is to 10 into 10 is 10. So the ratio will be 4, 5 and 10. So which one is maximum? See, first let's write it down. WA is 4, then WB is 5 and WC is 10, right? So which one is maximum? 10, that means WC is maximum, then 5, that means WB is next, and then 4, that means WA is least. Okay, so this is what we have to answer. So WC is maximum, that means option A will be the correct answer. Question number 40 is from the chapter friction, and the question is which one of the following statements is incorrect? Okay, so the first statement says rolling friction is smaller than the sliding friction. So this is a correct statement. Okay, we know that the maximum is static friction. Okay, static friction is maximum. Then the next is sliding friction, and the least is rolling friction. So obviously rolling friction is smaller than the sliding friction. Next is limiting value of static friction is directly proportional to the normal direction. This is also a correct statement. Then the third one is coefficient of sliding friction has dimensions of length. Now this is an incorrect statement because we know that frictional force is equal to coefficient of static sliding friction into normal force. Okay, so coefficient of sliding friction is equal to the frictional force divided by normal force. So both are forces, therefore it is dimensionless. That means this is an incorrect statement. Last one is frictional force opposes the relative motion. So this is also a correct statement, we know this. So the only incorrect one is option C. So option C is the correct choice here. Now question number 41 is from the chapter Systems of Particles and Rotational Motion, and the question is a moving block having mass m collides with another stationary block having mass 4m. The lighter block comes to rest after collision. When the initial velocity of the lighter block is v, then the value of coefficient of restitution, that is E, will be. Okay, so we have two blocks. One is lighter block having mass m and the other is the block having mass 4m. Okay, now let's see what are the initial and final velocities of these two blocks, initial and final. So initially the lighter one was moving with a certain velocity, let's say this is u1. Okay, and finally the lighter block comes to rest, so the final velocity of this, that is v1, becomes 0. Okay, now if we talk about the second one, here it was at rest initially, so u2 is equal to 0, and finally it starts moving with velocity v. So we can say that v2 is equal to v. Okay, now we'll use the law of conservation of momentum. So by using the conservation of linear momentum, we can say that the linear momentum will be conserved. That means the total initial momentum will be equal to total final momentum. That is m1 u1 plus m2 u2 will be equal to m1 v1 plus m2 v2, right? m1 is m, u1 is u1 plus m2 is 4m and u2 is 0. Okay, equals to m1, that is m, v1 is 0, then m2 is 4m, and v2 is v. Okay, so these 0 will become 0, right? So only mu1 will be left this side and 4m into v will be left this side. So m are same, m is cancelled, so we can say that u1 is equal to 4v. Okay, now we have to find out the coefficient of restitution. Coefficient of restitution, that is small e, is given by the formula v2 minus v1 divided by u1 minus u2. So let's put the values. v2 is equal to v minus v1 was 0, u1 is equal to 4v, we have just seen here, so we can put 4v in place of u1, minus u2 was equal to 0, so it is equal to v by 4v, that is 1 by 4, and we know that 1 by 4 is equal to 0.25, therefore 0.25 is the coefficient of restitution. That means option B will be the correct answer. Now question number 42 is from the chapter Laws of Motion, and the question is, a block of mass m is placed on a smooth inclined wedge ABC of inclination theta as shown in the figure. The wedge is given an acceleration a towards the right. The relation between a and theta for the block to remain stationary on the wedge is. Okay, so let's draw the figure again. We have a wedge like this, A, B, C. This angle is theta, and we have a block kept on this wedge. The mass of the block is m. Now let's consider the non-inertial frame. So considering a non-inertial frame, and let's assume that there is an observer at this point who will observe this block as stationary. Okay, so what are the forces acting on this block? One normal force will be acting in this direction. Okay, a downward force will be acting here, mg. Now if we resolve the components of normal force, then n sine theta will be acting in this direction, n sine theta, and n cos theta opposite to mg. Okay, also there will be a pseudo force opposite to n sine theta, ma, that is a pseudo force. Now, what are the conditions under which this block will remain stationary? It will remain stationary only if this n sine theta will balance this pseudo force ma, and n cos theta will balance the force mg. Okay, so according to that, n sine theta should be equal to ma. Let's say this is equation 1, and n cos theta should be equal to mg. Okay, this is equation 2. That means sin theta by cos theta will be equal to ma by mg. So sin theta by cos theta is equal to tan theta, right? Tan theta is equal to a by g. So now we have to find out the value of a. So a will be equal to g tan theta. Okay, so this is what is asked in this question. So out of the given options, the correct answer will be option C, A equals to g tan theta. Now question number 43 is from the chapter Electric Charges and Fields, and the question is, a toy car with charge q moves on a frictionless horizontal plane surface under the influence of a uniform electric field vector E. Due to the force q vector E, its velocity increases from 0 to 6 meter per second in 1 second duration. At that instant, the direction of the field is reversed. The car continues to move for 2 more seconds under the influence of this field. The average velocity and average speed of the toy car between 0 to 3 seconds are respectively. Okay, so basically it describes the motion of a car in total 3 seconds. Okay, so the total time considered time is 3 seconds, but the motion varies each second. Okay, so the time will be broken into 3 parts, that is from 0 to 1 second, then 1 to 2 seconds, and then 2 to 3 seconds. So in each of these time period, the motion will vary. Let's see how. Suppose this is the car. So in the first second, that is t equals to 0, to t equals to 1, it will move in the horizontal plane surface under the influence of electric field vector E. Okay. Now at this point where t is equal to 1 second, its velocity becomes 6 meter per second, whereas its initial velocity was 0 meter per second, right? Now after that, the direction of electric field is reversed, but the car moves for 2 more seconds. So for 1 second it will move in the same direction, and for the next 1 second it will move in the opposite direction. Okay. So here t is equal to 2 seconds. So 1 to 2 it will move in the same direction. And after that, from t equals to 2 seconds to t equals to 3 seconds, it will move in the opposite direction. Now remember that at the turning point the velocity will become 0. Okay, so the velocity will become 0 at the turning point. Now we'll first find out the acceleration of the car. So acceleration is equal to v minus u by t. So we'll consider the first part to find out the acceleration. So v1 minus u1 by t. So here the final velocity is 6 meter per second in the first part. That means 0 to 1 second. Okay, so at 1 second the velocity is 6 meter per second, minus initial is 0 meter per second because it started from rest. Time is 1 second. So it will be equal to 6 meter per second square. Now we'll use this acceleration at each step. So we'll start finding the distance traveled by the car. Okay. So for the first part, that is for t equals to 0 to t equals to 1 second. For this part, the distance, that is s1, will be equal to ut plus half at square. Now the initial velocity is 0, so ut will become 0. So it will be equal to half at square only. So half into 6 meter per second square into time is 1. So it will be equal to 3 meter. Okay, so in the first part it traveled a distance of 3 meters. This is the first part. Now for the second part, that is for t equals to 1 second to t equals to 2 seconds. That is s2 will also be equal to ut plus half at square. Okay, I just forgot to put a square here. Ut plus half at square, but this time ut is not 0 because the initial velocity is not 0. At this point the initial velocity is 6 meter per second because we had started from this point. So it is 6 into time is 1 second. Now it will be minus actually ut minus half at square. Okay, so it's not plus, it's minus. Okay, ut minus half at square because the direction of the electric field has been reversed. Okay, so minus half, acceleration is 6 meter per second square, time is 1 second, so 1 square. So on solving this we get 6 minus 3. Okay, so it will be equal to 3 meter again. So here also the car traveled the same distance, that is 3 meters. Now for the third part, that is for t equals to 2 seconds to t equals to 3 seconds. So S3 will be equal to again ut minus half at square. This time the initial velocity is 0 because it starts from the turning point, right? So at the turning point the velocity was 0. So ut will become 0, so it will be equal to half at square only. This is 0. So half into 6 into 1 square. And so it will be minus sign here, right? So it is minus 3 meter. Just the direction is changed. So minus 3 meter. 0 minus 3 is minus 3. Now what will be the net distance? First we'll find out the total displacement. Okay, total displacement will be equal to s1 plus s2 plus s3. So in displacement we also consider the direction, or we also consider the sign. So 3 plus 3 minus 3. Okay, so this will be equal to 3 meter. So the total displacement is 3 meter. So on the basis of displacement we can find out the average velocity. average velocity will be equal to total displacement divided by total time. So total displacement is 3 meter, total time is 3 seconds. So it will be equal to 1 meter per second. Okay, this is the average velocity. Now we'll find out the distance traveled. So total distance traveled, in this case we'll not consider the sign, we'll take it positive only. Okay, total distance will be S1 plus S2 plus S3. So it will be equal to 3 plus 3 plus 3. So it will be equal to 9 meters. Okay. And on the basis of total distance, we can find out the average speed. So it is equal to total distance divided by total time taken. So total distance is 3 meter, total time is 9 meter, and the total time is 3 seconds. So it will be equal to 3 meter per second. So two things were asked, average velocity was asked and average speed was asked. So average velocity is 1 meter per second and average speed is 3 meters per second. So the answer should be 1 and 3. That means option B will be the correct answer. Question number 44 is related to systems of particles and rotational motion. And the question is, the moment of the force vector F equals to 4i cap plus 5j cap minus 6k cap at this point 2, 0, minus 3. About the point, this is about 2 minus 2 minus 2 is given by. Okay. So let's say this is point P, this is point Q. So about this point Q, that means if this point is here, 2 minus 2 minus 2. Then this point P is here, 2, 0, minus 3. Then finding the difference between these 2 points, we can find out the vector R. Okay, because for the moment of force, we need to have vector F as well as vector R. Okay, moment of force is nothing but the torque. So let's find vector R. It will be the difference between these 2 points. So 2 minus 2 I cap plus 0 minus 2 j cap plus minus 3 minus 2 k cap. Okay, so 2 minus 2 is 0, so 0 I cap plus 0 plus 2, okay, that is 2 j cap plus 3 minus 3 plus 2, that means minus k cap. Okay, minus 1 k cap, minus 1 k cap. So it is 2 j cap minus 1 k cap. Okay, this is the vector R. And vector F is already given here. It is equal to 4 I cap plus 5 j cap minus 6 k cap. Now we have to find out the moment of force, that is torque. So that will be equal to vector R cross vector F. That means we have to find out the cross product of these two. So how do we do this? Here we'll write I cap, j cap and k cap. Then vector R is 0 I cap, then 2 j cap and minus 1 k cap, right? And force vector is 4 I cap, 5 j cap and minus 6 k cap. Now we'll find out the cross product. First we have to find out the I component. So for that we'll hide the I column and cross multiply j and k column. Okay. So it will be minus 6 into 2, that is minus 12 plus 5. Okay, minus 12 minus 5 into minus 1 is minus 5. So minus 12 minus minus 5 will be minus 12 plus 5 I cap minus sign. Then we'll hide the j column and we'll cross multiply I and k column. Okay, so minus 6 into 0, that is 0, minus 4 into minus 1, that is minus 4. Okay, so it will become plus 4 j cap, then plus sign. Now we'll hide the k column and cross multiply I and j column. So 5 into 0 is 0, minus 4 into 2 is 8 k cap. Okay, so it is minus 12 plus 5 will be minus 7 I cap, then minus 4 j cap, then minus 8 k cap. So this is our moment of force or the torque required. So which option will be the correct one? option C will be the correct answer. Okay. And now the last question is related to practical physics, and the question is, a student measured the diameter of a small steel ball using a screw gauge of least count 0.001 centimeter. The main scale reading is 5 millimeter and 0 of circular scale division coincides with 25 divisions above the reference level. If screw gauge has a zero error of 0.004 centimeter, the correct diameter of the ball is. Okay, so what is given in the question? Least count is mentioned as 0.001 centimeter. Main scale reading is given as 5 millimeter. So we'll convert it into centimeter, that is 0.5 centimeter. Then vernier scale reading is given as 25, as well as zero error is mentioned. Zero error is also given. It is 0.004 centimeter. So all are in centimeter. So what will be the diameter of the ball? Diameter can be calculated using the formula main scale reading plus vernier scale reading into least count plus zero error. So main scale reading is 0.5 plus vernier scale reading is 25, least count is 0.001 and zero error is 0.004. So on calculating this, we'll get 0.529 centimeter. That means option C will be the correct answer. Okay. So here we complete all the physics questions from NEET 2018 paper. I hope the things were clear to you. To have a better understanding of the questions, you can practice the questions from our website www.examsnet.com. For more help, download our app from the link given in the description. Till then, keep learning, keep scoring high. We'll get back with another session soon. Thank you so much. Hey champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So today we are going to discuss NEET 2018 chemistry questions and we are 45 questions here. So let's start the session. The first question is related to oxidation states and the question is the correct order of nitrogen compounds in its decreasing order of oxidation states is. Okay, so let's check the first one. Here, first one is nitric acid HNO3. Now suppose the oxidation state of nitrogen in this case is X. Okay, hydrogen has +1 oxidation state. We know that oxygen has -2. So we have 3 oxygens here. So -2 into 3. So the sum is 0, right? Then +1 plus X, then plus -6 will be equal to 0. Okay. So 1 and -6 will be -5. So X minus 5 equals to 0. So in this case, X will be equal to +5. So in this compound, the oxidation state of nitrogen is +5. Next is NO. Okay. NO. Now let's suppose the oxidation state is X and for oxygen we know it is -2. So X minus 2 is equal to 0. Then what will be the value of X? It will be equal to +2. So in this one, oxidation state of nitrogen is +2. Definitely it is less than the first one. Then third one is N2. Okay, pure nitrogen. So here we know that any pure element has the oxidation state 0. Okay, since this is pure element. Then the next one is ammonium chloride. Okay, NH4Cl. In this, again nitrogen will assume it as X. Okay, uh, it is X. Hydrogen has +4, so 4 hydrogen. Therefore, hydrogen has +1, so for 4 hydrogen it will be +4. And halogen has -1, so chlorine will have -1. Okay, so X plus 4 minus 1 will be equal to 0. X plus 3 will be equal to 0. So what will be the value of X in this case? It will be -3. Okay. So obviously here we can see that the oxidation state of nitrogen is decreasing. Okay. This was the last one. Okay. So it was +5, then +2, and then 0, and at last -3. Okay. So it is in decreasing order. So option A will be the correct answer. But still let's check for others as well. First one is nitric acid. Okay. For the second one, that is B number, nitric acid. This is plus 5. We had seen earlier. It was plus 5 for nitric acid. The next one is NO. For NO it is plus 2. Again it is decreasing. Next one is ammonium chloride. Ammonium chloride. So we have seen that for ammonium chloride it is minus 3. And at last we have pure nitrogen, which is 0. So as we can see, it is not in the decreasing order. Okay, 0 has come later. Therefore, this is not correct. Okay, this is not in the decreasing order. For the third one also, ammonium chloride. So for ammonium chloride, it is 0. Then sodium nitrite. So sodium is an alkali metal, right? So plus 1 plus X minus 2 equals to 0. So X minus 1 equals to 0. So X will be plus 1. So the next one, that is sodium NaNO, is plus 1. Okay, so it is clear that it is not in the decreasing order. So this is also not correct. Then the last one also you can check in the similar way. It is also not in the decreasing order. So the only answer is the option A. Now question number 47 is from the P block elements, and the question is the correct order of atomic radii in group 13 elements is. Okay, so first of all let's list the group 13 elements here. What is the sequence of elements in group 13? It is boron, then aluminium, gallium, indium and thallium, right? Now we know that on moving down the group, the atomic radii increases, right? On moving down the group, atomic radii, that means size of the elements increases, right? So boron will have minimum size and thallium will have maximum size, or we can arrange these elements in the general trend of increasing order of size. Okay, so according to the general trend, the atomic radii should vary in this order. Boron should be minimum, then aluminium, then gallium, then indium and then thallium. Okay, but this is not the correct answer because there is an exceptional case between aluminium and gallium. Okay, so here you have to remember that gallium has a smaller radius as compared to the aluminium. Okay, and what is the reason? The reason is that gallium has poor shielding effect in its d orbital. Okay, so the d orbital of gallium has poor shielding effect which decreases the which increases the nuclear charge, right? Due to poor shielding effect, the nuclear charge will increase. Nuclear charge. And when the nuclear charge increases, the outermost electrons will be pulled towards nucleus. Okay, electrons are pulled towards the nucleus, or they are attracted towards the nucleus, thus decreasing the size. Okay, so size decreases. Therefore the correct order will be like this: boron, then gallium, then aluminium, and then the general trend, that is indium and thallium. Okay, so let's see which is the correct order. So option C will be the correct answer. Question number 48 is from the chapter General Principles and Processes of Isolation of Elements. And the question is, considering Ellingham diagram, which of the following metals can be used to reduce alumina? Options are iron, zinc, copper and magnesium. So basically it is asked that which of the given metals is more reactive than aluminium. Okay, the metal M should be more reactive than aluminium, and it is given that it can be used to reduce alumina. So for that, just keep in mind one reaction, that this is alumina Al2O3. So if this will react with a metal M, then what will be formed? It will be reduced to aluminium and the metal will be oxidized to metal oxide, okay, M2OX. So this reaction from metal to metal oxide should be more negative, okay, that means delta G naught value should be more negative. And how can we determine this if this metal has more negative delta G naught value? With the help of Ellingham diagram. So what is Ellingham diagram? It is a graphical representation of Gibbs energy flow. Okay, it is a graphical representation of Gibbs energy flow. So in this, basically delta G naught values are plotted in relation to the temperature. And it will look something like this. On the x-axis we'll have temperature. On the y-axis we'll have delta G naught values. And as you move down, the values will become more negative. Okay, more negative. And more negative delta G naught values will mean that the metal is more reactive, because the reaction will take more, spontaneously. So here it is basically we have to determine that which of the given metals reaction will be shown at the bottom side. Okay, it should have more negative values. So let's compare the delta G naught values of the given options. So delta G naught of magnesium is most negative. Okay, this is most negative among the given options. And then next is delta G naught value for aluminium, then delta G naught value for zinc, then delta G naught value for iron, and at last we have delta G naught value for copper. This is least negative out of the given options. Okay, so the graph for copper will be shown at the top side, and then the graph for delta G naught value for magnesium will be shown at the bottom side. So we can see that out of the given metals, there is only one metal, that is magnesium, which has more negative delta G naught value as compared to aluminium. All others have less negative, that means all others are less reactive than aluminium. Okay, and only magnesium is more reactive than aluminium, right? So this is more reactive than aluminium, therefore it will be able to reduce the alumina. Okay, so option D will be the correct answer. You can go through your book, NCERT book, to see the diagram more carefully. Question number 49 is again from the P block elements, and the question is, which one of the following elements is unable to form Mf6 3- ions? So that means hexafluoride, right? Metal hexafluoride. Now we can see that the elements that are mentioned in the given options are all from group 13. What are the group 13 elements? Boron, then aluminium, then gallium, indium, and thallium, right? Now, the correct answer will be option D, that is boron. It will be unable to form Mf6 3-. The reason is that boron has no vacant d orbital in its valence shell. Okay, let's write it down here. Boron has no vacant d orbital in its valence shell. So it can't extend its covalency beyond 4. It will not be able to extend its covalency beyond 4. That means it will not be able to accommodate more than 4 pair of electrons in its outermost shell. Okay, but if we talk about all the other elements of group 13, so they all have vacant d orbitals. Vacant d orbitals. Thallium even have F subshell. So what does this mean? That due to the presence of vacant d orbitals, they can be able to accommodate 6 pairs of electrons easily. Okay, So boron is the exception, therefore it will not be able to form MF6, and that is why option D is the correct answer. Now question number 50 is from the P block elements again, and the question is which of the following statements is not true for halogens. Okay, so halogens are group 17 elements. Now let's go through the statements. The first statement says all form monobasic oxyacids. What are monobasic oxyacids? These are the acids that have only one replaceable hydrogen ion, right? Only one replaceable hydrogen ion. Now there is an exception in this case, that is fluorine. Fluorine forms only one oxyacid, that is HOF, and that too it is an unstable oxyacid. Okay, so although it exists, it is an unstable oxyacid due to which it breaks into fluorine and oxygen. Breaks into fluorine and oxygen. Therefore, we cannot say that fluorine forms monobasic oxyacids. All others form monobasic oxyacids. So this will be the incorrect statement. Okay, if there would be an exception mentioned in this statement, then this statement would have been correct. But since all is mentioned, so this is not correct. So here only we have got our incorrect statement. But still, let's go through the other options as well. The second statement says all are oxidizing agents. This is a correct statement. What is the reason? Reason is that the number of electrons in the outermost shell of halogens is 7 electrons, right? 7 electrons in the outermost shell. That means they need only one electron to complete the octet, right? Need only one electron to complete the octet, and due to this they readily gain or accept the electron. Readily gain one electron, and that is why they are good oxidizing agents. Oxidizing agents, and there is no exception in this case, therefore this statement will be correct. Now we move to the third statement. It says chlorine has the highest electron gain enthalpy. Again, this is a correct statement. See, we know that if we talk about the electronegativity, then we can say that fluorine is more electronegative than chlorine. But if we talk about the electron gain enthalpy, then in this case chlorine has more electron gain enthalpy as compared to fluorine. The reason is that chlorine has more repulsion domination. Okay, repulsion domination. That means the electrons are repelled in this case, and due to that it has higher electron gain enthalpy. Then we move to the last statement. It says all but fluorine show positive oxidation states. It means that except fluorine, all show positive oxidation state, and that is also true. We know that due to the small size and anomalous behavior of fluorine, it shows only one oxidation state, that is -1. Okay, only -1 oxidation state. Oxidation state. Whereas all other halogens show positive oxidation states as well. They can show +1, +3, +5 and +7 oxidation state as well. Okay. Therefore, this statement is also correct that except fluorine, all show positive oxidation states. So, since it is asked that which of the statements is not true, therefore only option A will be the correct answer. Now, question number 51 is related to chemical bonding and molecular structure. And the question is, in the structure of chlorine trifluoride, the number of lone pairs of electrons on central chlorine is, options are 1, 2, 3 and 4. So for that, let's draw the structure of chlorine trifluoride. This is the central atom, that is chlorine. Okay. 3 fluorine atoms are joined with it. So one fluorine atom this side, then one fluorine atom, and the third one here. Okay, so obviously it will share one electron with each fluorine atoms. Okay, now how many electrons are there in the outermost shell of chlorine? 7 electrons, out of which 3 are shared with fluorines. Okay, 3 are shared with 3 fluorine atoms. So how many left? 4 are left. Okay, so 4 electrons left, or we can say two pairs of electron left. Okay, so how many lone pairs? Two lone pairs, one lone pair and two lone pair. Okay, so this is how all the 7 electrons are uh, exist around the chlorine atom. Okay, so option B will be the correct answer because two lone pairs of electrons are there. Question number 52 is from the chapter Biomolecules, and the question is the difference between amylase and amylopectin is. Options are, the first one is that amylopectin have 1,4 alpha linkage and 1,6 alpha linkage. So for that, let's see what are the amylose and amylopectin. So amylose and amylopectins are nothing but they are polymers of alpha D glucose units. Okay, alpha D glucose units. So obviously, since only alpha D glucose exists, therefore there is no chance of beta linkage. So we can easily eliminate the options having beta linkage. So in the second option, beta linkage is mentioned, so just eliminate it. And then in the last one also, beta linkage is mentioned, so this is also eliminated. Also, we know that only alpha D glucose units exist, glucose unit, not galactose. Therefore, option C is also eliminated. So it is quite clear that only option A is the possible answer. Okay. So let's see the difference between amylose and amylopectin is that amylose is the linear polymer. Okay, amylose is a linear polymer, whereas amylopectin is branched polymer. Amylopectin is branched polymer. And what kind of linkage exists in case of amylose? These units are, the monomer units are held by C1 C4 glycosidic linkage. Okay, glycosidic linkage. In case of amylopectin also, the straight or the linear chain is held by C1 C4 glycosidic linkage, C1 C4, but the branching occurs at by C1 C6 glycosidic linkage. Okay, glycosidic linkage. Therefore, option is the correct, that amylopectin have 1,4 alpha linkage and 1,6 alpha linkage both. Okay, 1,4 in case of linear one and 1,6 at the branching point. Okay. Now question number 53 is from the chapter Polymers, and the question is regarding cross-linked or network polymers, which of the following statements is incorrect? So the first statement says they contain covalent bonds between various linear polymer chains. So this is a correct statement. Okay, suppose this is chain 1, this is polymer chain 2, then between these two chains there will be strong covalent bonds. Okay, strong covalent bonds. Now we move to the second statement. It says they are formed from bi and tri-functional monomers. This is also a correct statement. Then we come to the third one. They contain strong covalent bonds in their polymer chains. Now this is not a characteristic of cross-linking polymers. So this is not true. Okay. Although covalent bonds exist between different linear chains, but it does not exist within one polymer chain. Got it? So suppose this is chain 1. See, we have seen just now. So the strong covalent bond does not exist between this chain only. Okay. In between this chain, no strong covalent bond will be there, but it will exist between two different chains. Okay. That is the difference between statement 1 and statement 3. Then the last one is examples are bakelite and melamine. This is also correct. These are the examples of cross-linking polymers. So the only incorrect statement is statement C. So option C is the correct answer. Now question number 54 is from some basic concepts of chemistry, and the question is a mixture of 2.3 grams formic acid and 4.5 grams oxalic acid is treated with concentrated sulfuric acid. The evolved gaseous mixture is passed through KOH pellets, that is potassium hydroxide pellets. Weight in grams of the remaining product at STP will be. Okay, so let's write down the reaction for each of them, formic acid as well as oxalic acid. So we'll write the reaction for formic acid this side and the reaction for oxalic acid this side. So formic acid is HCOOH. Now first it is treated with concentrated sulfuric acid, that is H2SO4. So what are the products obtained? Carbon monoxide plus water. Okay. Now, as it is clear from this reaction that for each mole of formic acid used, 1 mole of each of the products is obtained, right? So how many moles of formic acid are present in this? In this case, it will be given mass by molar mass. So given mass is 2.3 grams, molar mass is 46, okay, for formic acid. So on solving this, we get 1 by 20 moles. So 1 by 20 moles of formic acid are present. Therefore, 1 by 20 moles of carbon monoxide will be formed, as well as 1 by 20 moles of water will be formed. Okay. Similarly, we'll see for oxalic acid as well. This is H2C2O4. This is also treated with concentrated sulfuric acid. Now this time we get carbon monoxide as well as carbon dioxide, and water is also there. So here also for each mole of oxalic acid, 1 mole of each of the products is formed, right? So how many moles of oxalic acids are there? Given mass by molar mass again. So given mass is 4.5 grams for oxalic acid. Molar mass is 90. So in solving this again we get 1 by 20. So for 1 by 20 moles of oxalic acid, 1 by 20 moles of carbon monoxide will be formed. 1 by 20 moles of carbon dioxide will be formed, and 1 by 20 moles of water will be formed. Okay. So this is the basic reaction. Now we know that concentrated sulfuric acid acts as a dehydrating agent. That means it will absorb water. Okay, it will absorb water. So water will be absorbed by concentrated sulfuric acid. Then we have KOH pellet as well. The evolved gaseous mixture are passed through KOH pellets. So these pellets will absorb carbon dioxide. Okay, these are potassium hydroxide is known for absorbing carbon dioxide. So these two things will be absorbed. So what is left? Only carbon monoxide is left. Okay, only carbon monoxide is left. So we have to find out what gram of carbon monoxide will be left. Okay, we have to find the weight in gram. So for that, first we'll know the total number of moles. Total number of moles of carbon monoxide. So 1 by 20 in this case, in case of formic acid, and 1 by 20 in case of oxalic acid. Okay. So 1 by 20 plus 1 by 20. So we'll get 1 by 10 moles. Okay. This is the total number of moles of carbon monoxide. And we know that number of moles is equal to given mass by molar mass. Okay. So we can say that 1 by 10, that is number of moles, is equal to given mass. We don't know the mass, that is what we have to find out, but molar mass we know. So this is molecular mass or molar mass 28. So we can find out the mass, that is 28 divided by 10, right? 28 divided by 10. So on solving this we'll get 2.8 grams. So this is the amount of carbon monoxide that is left. Therefore option D will be the correct answer. Now let's move to question number 55. It is from the chapter S block elements, and the question is, which of the following oxides is most acidic in nature? Now options are magnesium oxide, beryllium oxide, calcium oxide and barium oxide. So as it is clear from the given options that all the elements mentioned here are from group 2. Okay, so all these are group 2 elements, right? Group 2 elements. What is the sequence of elements in group 2? It is beryllium, then magnesium, then calcium, strontium, barium and radium. So out of them, how many are mentioned? Beryllium is mentioned, magnesium oxide is mentioned, calcium oxide is mentioned and barium oxide is mentioned. Now here we have to remember that group 2 elements, they make basic oxides. Okay, they form basic oxides. So all of them, almost all, are basic oxides except beryllium. Beryllium is an amphoteric oxide. Beryllium forms the amphoteric oxide. That means it can act as an acid as well as base. So the only possibility of being an acidic oxide is for beryllium oxide. Okay. Therefore, this will be the correct answer. All others are basic. Others. Also, we should remember that as we move down the group, the basic nature of the oxides increases. Okay, as we move down the group basic nature of their oxides increases. Okay, so according to the question, our answer is option B, beryllium oxide. Question number 56 is from the chapter amines, and the question is nitration of aniline in strong acidic medium also gives metanitroaniline because option A, in spite of substituent, nitro group always goes to only meta position. Option B, in electrophilic substitution reactions, amino group is meta directive. Option C, in strong acidic medium, aniline is present as anilinium ion. And the last one is in absence of substituents, nitro group always goes to meta positions. Now the correct answer will be option C, that in strong acidic medium, aniline is present as anilinium ion. So let's see what happens. This is our aniline, this is benzene ring, this is NH2. So this is aniline. Now as we know that nitration will take place in an acidic medium, so H plus ion will be there, and this NH2 is a basic group, right? So we can see that there is presence of a base as well as acid in this reaction. Therefore, an acid-base reaction will take place, and therefore this basic group will accept this proton. Okay, so it will form NH3 minus. So this is the benzene ring, NH3 minus. That means it will form an anilinium ion. Now, what is the importance of this anilinium ion? We know that NH3 is a meta-directing group. Okay, meta-directing group because it will show minus I effect. Okay, that is, it will withdraw the electron withdrawing. Okay, therefore meta-nitroaniline will also be formed. Okay, but ortho and para will also be formed. See, the para will be 50%, ortho will be 2%, and meta product will be 47%. Why this ortho product is very less? Because since the minus I effect is maximum near ortho position. Okay, ortho position, therefore density of electron density is minimum at this position. Okay, so that is why option C will be the correct answer. Now question number 57 is from the chapter alcohols, phenols and ethers, and the question is a compound A on treatment with sodium gives B and with PCl5 gives C. B and C react together to give diethyl ether. A, B and C are in the order. Okay, so we have a compound A which on reaction with sodium gives B, and on reacting with PCl5 it gives C. Okay, this is C, and this side we get compound B. Now we'll see what B and C are, but let's focus on the second part of the question. It says that B and C react together to give diethyl ether. So B plus C give diethyl ether, that means C2H5O C2H5. Okay, this is diethyl ether. So this reaction seems like Williamson synthesis. We know that Williamson synthesis is the reaction of formation of ethers, okay, in which one of the reactants is an alkoxide and the other is an alkyl halide. Okay, so one should be alkyl halide, this one should be an alkyl halide, and the first one should be an alkoxide. Now since B is formed after reaction with sodium, so this should be sodium alkoxide, right? This should be sodium alkoxide, and C is formed after reaction with PCl5, so it should be alkyl chloride. Okay, alkyl chloride. That means the general form of B should be RONA, and the general form of C should be RCl. Okay, so from this only we can find out the correct answer. For example, if we look at the first option here, we can see the B. We have to find in the order A, B and C, right? So the first one should be A, then second one should be B, and the third one should be C. So B is not an alkoxide, so this is not the correct answer. Okay, C is an alkyl halide, so this is correct, but B is not an alkoxide, so this cannot be the correct option. Then in the second one, B is an alkyl halide, C is an alkoxide. So again, this is not correct. Alkoxide should be B and alkyl halide should be C. Okay. In the third one, the B is sodium alkoxide and C is alkyl chloride, as we had just discussed. So this seems to be the correct answer. Okay. Now let's see what is the number of carbon atoms in each of the reactants. So for that, A should be an alcohol, right? So this alcohol with sodium will give us sodium alkoxide. So let's write down the reaction. The most suitable is ethyl alcohol, that is C2H5OH. So we'll write down the reaction. The compound A, that is C2H5OH. This is compound A. It will react with sodium and it will give us sodium alkoxide, and more specifically sodium ethoxide. Okay. This is compound B. And on reaction with PCl5, it will give us ethyl chloride, C2H5Cl. So this is the compound C. So now we are confirmed that option C is the correct answer. Question number 58 is from the chapter Haloalkanes and Haloarenes. And the question is, hydrocarbon A reacts with bromine by substitution to form an alkyl bromide, which by Wood's reaction is converted to gaseous hydrocarbon containing less than 4 carbon atoms. So A is, okay, we have to tell what is that hydrocarbon A. Now, we can see here that two types of reactions are taking place. First, a substitution reaction is taking place, and then a Wood's reaction is taking place, right? Now, substitution reaction, we have a hydrocarbon A that reacts with bromine to give alkyl bromide. Okay. Now, here we know that in case of substitution, this bromine will replace one of the hydrogens of this hydrocarbon A. That means the number of carbon atoms will remain same before and after the reaction. So if this hydrocarbon A has n number of carbon atoms, then alkyl bromide formed after the reaction will also have the same number, that is n number of carbon atoms, right? So this is the first reaction. Now second reaction is Wood's reaction. So what happens in Wood's reaction? In this, an alkyl halide, okay, this is alkyl halide, reacts with sodium in dry ether to give us a hydrocarbon containing double the number of carbon atoms as present in this alkyl halide. So if this alkyl halide has n number of carbon atoms, then the hydrocarbon that will be formed after the reaction will have 2n number of carbon atoms. Okay, so it will be RR, 2n carbon atoms, double, right? And in addition to that, sodium halide will be formed. Now, here also this alkyl bromide will undergo Wood's reaction. Alkyl bromide will undergo Wood's reaction. Then what will be obtained? A hydrocarbon containing double the number of carbon atoms. Okay, and it is given in this question that this hydrocarbon contains less than 4 carbon atoms. This has less than 4 carbon atoms. That means this alkyl bromide should have less than 2 carbon atoms, right? So which of the given options has less than 2 carbon atoms? Option C. Therefore, option C will be the correct answer. Now, question number 59 is again from the chapter Haloalkanes and Haloarenes. And the question is, the compound C7H8 undergoes the following reaction. So first, this react with chlorine in high temperature to give the compound A. This compound A reacts with bromine and iron to give the compound B. And finally, this compound B reacts with zinc and HCl to give the final product, that is C. Okay. So we'll start with the first one. First, we have C7H8, right? So this is the compound. This is nothing but methyl benzene, that is also commonly known as toluene. Okay. So this is toluene. Now, in the first reaction, it reacts with chlorine 3Cl2 in high temperature, okay, under high temperature. So basically, side chain chlorination will take place, okay, whenever chlorination takes place at high temperature or under the UV radiation of sun, then side chain chlorination takes place. So let's draw the product that will be obtained here. CCl3 will be obtained. Okay, this is the compound A. So we can see that 3 chlorine atoms have replaced 3 hydrogen atoms in the methyl group, right? Now, next reaction is with bromine and iron. Okay, so what will be formed here? This CCl3 will remain here and bromine will get added at some position. And at what position? At meta position, because CCl3 group is meta directing group. Okay, this is meta directing group. Now, finally, this is the product B, right? This is product B. Now this reacts with zinc and HCl. So what will be formed? The 3 chlorine atoms that had been added to the carbon are again replaced by the 3 hydrogen atoms. Okay, so we get the methyl group again, but this bromine will remain attached here. So the final product will be meta bromo toluene, right? Meta bromo toluene, that means option A will be the correct answer. Now question number 60 is from the chapter Environmental Chemistry, and the question is, which oxide of nitrogen is not a common pollutant introduced into the atmosphere both due to natural and human activity? So options are N2O5, NO2, NO and N2, right? We know that pollutants are of two types. First, that are natural, and the other that are produced due to human activities. And oxides of nitrogen are examples of such pollutants. So here you can see that out of the given options, only the first one is the oxide of nitrogen, that is not a common pollutant, right? But all others are common pollutants that are introduced into the atmosphere as natural pollutants, as well as they are produced due to human activities. Okay, so option A will be the correct answer. Now question number 61 is related to chemical bonding and molecular structure, and the question is, which of the following molecules represents the order of hybridization sp2 sp2 sp sp from left to right atoms? Okay, so we know that three types of hybridizations are there: sp3 hybridization, sp2 hybridization and sp hybridization. Okay, in case of sp3 hybridization, all sigma bonds are there. Okay, all sigma bonds. In case of sp2, one pi bond is there and one sigma bond is there. Okay, in case of sp, two pi bonds are there and one sigma bond. So let's check one by one. In the first one, the first carbon has one sigma bond with hydrogen and two pi bonds here. Okay, so it is two pi bonds, that means sp hybridized. Okay, the next carbon again has two pi bonds, so this is also sp hybridized. Then the third carbon again has two pi bonds, so it is also sp hybridized, and the last one also is sp hybridized. Okay, now this cannot be the correct answer. Then next one, the first carbon has two sigma and one pi. Okay, one pi means sp2 hybridized. Then the second carbon has again one pi, so this is also sp2 hybridized. Third carbon has 2 pi, so this is sp, and the fourth carbon also has 2 pi, so this is also sp. So according to the sequence that is mentioned in the question, this should be the correct answer. Still, let's check for others also. In the third one, the first carbon has all sigma bonds, so this is sp3 hybridized. Second one has again all sigma bonds, so this is also sp3 hybridized. Then the third one, sorry, this is sp2 hybridized because it has one pi bond also. Okay, so the second one is sp2 hybridized, third one is also sp2 hybridized, it also has one pi bond, and the last one is sp3 hybridized. Okay, now in the last one, the first carbon has one pi bond, so sp2. Second also has one pi bond, so this is also sp2. Third carbon has again one pi bond, so sp2. and the last also has one pi bond, so this is also sp2. So according to the question, the only correct option will be option number B. Now question number 62 is related to organic compounds containing nitrogen, and the question is which of the following carbocations is expected to be most stable. Okay, so if we look at the given options, we can see that all contain NO2 group, okay, nitro group, and we know that nitro groups are electron withdrawing groups, okay, electron withdrawing groups because they exhibit minus I effect, okay, minus I effect, and this effect goes on decreasing as the distance increases, okay, so it decreases with increase in distance. So since here positive charge is present, so we can see that in which of the given options this positive charge is at maximum distance from the nitro group, okay, so that will be the most stable one. So in the first one this is at meta position, in the second one it is at just the adjacent carbon, that is the carbon just the adjacent to the nitro group, so this cannot be the stable one, okay, because it is already of electron withdrawing nature and here positive charge is there, so it will be mostly unstable, okay. In the third one also it is at the same location, so this is also not stable, and in the last one this is at maximum distance, okay, this is at para position, so this will be the most stable one, and the second and third are very less stable, okay, these are the highly unstable ones. So out of the given options, our correct answer will be option number D. Question number 63 is again related to organic compounds, and the question is which of the following is correct with respect to minus I effect of the substituents. R is the alkyl group, okay, so minus I effect, now we know that minus I effect increases on increasing the electronegativity on atom, on increasing the electronegativity of atom. So basically we have to compare the electronegativity of the given atoms in the sequence. So if you look at the given options, you can see that all have one thing in common. The first one contains nitrogen, second one contains oxygen, and the third one has only fluorine, right? So out of nitrogen, oxygen and fluorine, which one has highest electronegativity? Fluorine, okay? So fluorine is most electronegative elements, and the second one is oxygen, and nitrogen is least electronegative out of the given options. Therefore the sequence should be in this order. So according to this, option A and option B both should be the correct sequence, right? So I don't know if there is any mistake in this question, but the sequence of both A and B are correct. Now question number 64 is from the chapter alcohols, phenols and ethers, and here a reaction is given, and the question is that in the reaction the electrophile involved is, okay, so this is the Reamer-Tiemann reaction, Reamer-Tiemann reaction. So it is basically an electrophilic substitution reaction, right? Electrophilic substitution reaction. And here a chloroform reacts with a base, okay, so we know that since this is an electrophilic substitution reaction, so the first step should be the generation of an electrophile, and let's see how it happens. The chloroform, that is CHCl3, reacts with a base, so OH minus ion will be there in the base, right? So what will happen? These chlorines are electron withdrawing in nature. So electrons will be attracted toward them, and this electron that is involved in the bond between carbon and hydrogen will also move from here to the carbon. Okay, and this electron OH minus, this will also move from here to here. So what will be formed here? CCl3 minus with a lone pair of electrons, right? And in the next step, one electron will be removed, okay, one electron will be removed, and what will be formed? CCl 2 with a lone pair of electrons. Okay, and this will act as an electrophile. This will be the required electrophile that is going to attack the phenol that is shown as the reactant in the given reaction. Okay, so it will attack the phenol, forming the product that is salicylaldehyde. Okay, what product will be formed? The product that is shown in the given reaction is salicylaldehyde. Salicylaldehyde. So basically what was asked in the question, what is the electrophile involved, right? So this CCl2 with a lone pair of electron, that is dichlorocarbene, is the required electrophile. So option C is the correct answer. Question number 65 is from the chapter aldehydes, ketones and carboxylic acids. And the question is, carboxylic acids have higher boiling points than aldehydes, ketones and even alcohols of comparable molecular mass. It is due to their option A, formation of intramolecular hydrogen bonding, option B, formation of carboxylate ion, option C, formation of intermolecular hydrogen bonding, and the last option is more extensive association of carboxylic acid via van der Waals force of attraction. So the correct option is option C, that is formation of intermolecular hydrogen bonding. Okay, so what happens due to the formation of intermolecular hydrogen bonding in carboxylic acids? Association occurs. Okay, hence the boiling points increases. So due to this, the boiling point increases and it becomes more than the boiling points of aldehydes, ketones and alcohols of comparable molecular masses. Okay, so this is the required answer. Now question number 66 is from the chapter aldehydes, ketones and carboxylic acids, and the question is, compound A C8H10O is found to react with sodium hypoiodide produced by reacting Y with sodium hydroxide and yields a yellow precipitate with characteristic smell. A and Y are respectively. Okay, so we have to identify A as well as Y. So first we'll identify Y. We know that sodium hypoiodide is formed by the reaction between sodium hydroxide and iodine. Okay, so this reaction will give us sodium hypoiodide. So it's quite clear that Y is nothing but iodine, right? And it is already mentioned in all the given options. Okay, iodine is mentioned as Y in all the options. So it is quite clear. Now we have to identify the compound A. So here we should know that this question is basically talking about the iodoform test. Iodoform test, because sodium hypohalite is used in this test. Okay, and which type of compounds give iodoform test? Compounds having carbonyl group, that means carbon double bond O. And which type of compounds having carbonyl group? This type of, that means methyl group and carbonyl group should be methyl group, and this oxygen should be attached to the same carbon, right? Now in all the given options there is no carbonyl group mentioned, so we can see that all contain alcohols. So which type of alcohol will give the iodoform test? Alcohol of this form. Methyl group should be attached to one carbon, and to the same carbon OH should be attached. Okay, that means a secondary alcohol. This is a secondary alcohol. So first this secondary alcohol will get converted into this form and then it will give the iodoform test. Okay, so let's see in which of the given options there is such type of alcohol present. That means methyl and OH group should be attached to the same carbon, right? So in the first option we can see that methyl group is attached to this carbon, but OH is attached to another carbon. So this is not possible. In the second option, no methyl group is present. So this is also incorrect. In the third one, this is the methyl group. This is attached to this carbon and OH is attached to this carbon. So this is also incorrect. In the last one, we can see this is the methyl group. This is the OH and both are attached to the same carbon, right? So obviously this is the correct answer. Also, it is mentioned that compound A is C8H10O. That means 8 carbons are there. So you can see this benzene ring contains 6 carbon. Then the next carbon, 7 carbon and then 8 carbons. Okay, total this is 8 carbon. So it is quite clear that option now let's see how will this reaction proceed, right? So first we have this compound. This is the benzene ring. We have carbon. Here we have methyl group. And here we have OH. This is the compound A, right? So this will react with sodium hypoiodide, that is formed by reaction between sodium hydroxide and iodine. Okay. So first it will get converted into a ketone, that is acetophenone. Okay. So here OH will be converted into C double bond O, and then methyl group will be there. Now this compound will give the iodoform test. So iodine plus sodium hydroxide. So what do we get here? We get two things. First, we get a sodium benzoate, that means a salt. So this is the benzene ring. Here we get COONA. So this is one of the products. Plus another product is CHI3, that is nothing but iodoform. Okay. So iodoform will be formed as one of the products. Okay. And this is the yellow precipitate that is mentioned in the question. Okay. This is the yellow precipitate. Okay, so our answer is option number D. Question number 67 is from the chapter Alcohols, Phenols and Ethers, and the question is identify the major products P, Q and R in the following sequence of reactions. So we can see that in the first step this benzene ring is reacting with an alkyl chloride in the presence of anhydrous aluminium chloride to give a compound P. Okay, so from this step it is clear that this is the Friedel-Crafts alkylation reaction. And what happens in case of Friedel-Crafts alkylation reaction? First, an electrophile is generated. Okay, so the first step will be the generation of an electrophile. Generation of an electrophile. And how will this happen? It will happen by the reaction between this alkyl chloride and anhydrous aluminium chloride. Okay, so our alkyl chloride is CH3, CH2, CH2, Cl. It will react with anhydrous aluminium chloride. So the chlorine from the alkyl chloride will move to the anhydrous aluminium chloride. So what will be formed? Here, since chlorine contains a negative charge, so negative charge will be removed from alkyl chloride and a positive charge will develop. Okay, so it will become CH3, CH2, CH2 plus. Okay, that means a carbocation is formed. Plus this side chlorine has been added, so it will become AlCl4 minus. Okay, because chlorine contains a negative charge. Now we know that carbocations rearrange themselves in order to get more stable. So this carbocation will also tend to become more stable. So what will be the stable form of this carbocation? The stable form will be CH3CH CH3. Okay, that means one hydrogen from the middle carbon has moved to the corner. Okay, so this is the stable form of carbocation, and this will act as the electrophile. Okay, this will act as the electrophile. That means it is going to attack the benzene ring. Okay, so let's see. We'll do this step again. The electrophile, that is CH3CH plus CH3, will attack the benzene ring. It will just get added to the benzene ring. So we have CH, CH3, CH3. Okay, so this electrophile has been added to the benzene ring, right? So this is our compound P. So let's see, in the first one only one methyl group is there, so this is not the correct answer. In the second one also only one methyl group. In the third and fourth, two methyl groups are there, so either third or fourth is possible here. Okay, now let's see what happens next. This, in the given reactions, given sequence of reaction, this P further reacts with oxygen, right? So this P will react with oxygen. So this oxygen O2 will just enter between these two, carbon and hydrogen. So let's see what happens. This is the benzene ring. Here we have methyl group this side, one methyl group this side, and between carbon and hydrogen O2 will enter, so OOH. Okay, and then hydrolysis is done, H3O plus. So on hydrolysis, only phenol will be left here. Okay. So phenol will be left here, and that will be the compound Q. In addition to that, we know that this part will be removed, then only phenol will be formed. So this part will be removed as ketone. Okay. That is acetone more specifically. Okay. Acetone. So this is the compound R. So Q is a phenol and R is acetone. Therefore, we can say that this third one is the correct one. Okay. Also remember that this is the industrial method for the production of phenol. Okay. So our options are given at the bottom. Okay. Third one is the correct. Okay. So third one, that means option A will be the correct answer. Okay. It mentions that third one is the correct sequence. So this is the correct answer. Question number 68 is from the chapter Biomolecules, and the question is, which of the following compounds can form a Zwitter ion? Okay, so what is Zwitter ion? It is a molecule or ion having separate positively and negatively charged groups. Okay, so Zwitter ions contain positively charged as well as negatively charged groups. Okay, charged groups. That means the compound should have an acidic part as well as basic part in order to form Zwitter ions. Okay, so let's see. The first one is aniline. Aniline. So what is the structure of aniline? This is the benzene ring. Okay, and here we have NH2. So this has the basic part, right? This has the basic group, but no acidic group. No acidic group. Therefore, it will not form the Zwitter ion, right? Then the second one is acetanilide. Acetanilide. So let's see the structure. The benzene ring is there. Then we have NH, C double bond O, CH3. Again, basic group is there, but no acidic group is there. No acidic group. Therefore, this will also not form the Zwitter ions. If we talk about the third one, that is glycine, this will be the correct answer because it will form Zwitter ion. Okay. The structure of glycine is NH2, CH2, COOH. So it is clear from here that it contains an acidic group as well as a basic group. Okay. So NH2 is the basic group and COOH is the acidic group. So the Zwitter ion that it will form is NH3 plus CH2 COO minus. Okay, so this is the positive charge, this is the negative charge. Okay, this is the Zwitter ion. Therefore, option C is the correct answer. If you want to check the last one, that is benzoic acid, we can draw the structure of benzoic acid as well. This is the benzene ring and this is COOH. So it is clear that only acidic group is there. Okay, only acidic group is there and no basic group is there in benzoic acid. Therefore, it is also not going to form the Zwitter ion. So only correct option is option number C. Question number 69 is related to oxidation states, and the question is for the redox reaction. So this reaction is given here. The correct coefficients of the reactants for the balanced equation are. Okay, so we have to find the correct coefficients of the reactants. That means MnO4 minus, C2O4 2 minus and H plus. Okay, all these three reactants. So first we'll see how the oxidation states are changing. If we talk about MnO4 minus, suppose the oxidation state of manganese is X here. So 4 oxygen, that means 4 into minus 2. So it will be X minus 4 into minus 2, that is minus 8, will be equal to minus 1. Okay, because the overall charge is minus 1. So from here we get X equals to plus 7. So the oxidation state of manganese on the reactant side is plus 7. On the product side it is Mn2 plus. That means X equals to plus 2 here. So this time what is happening, plus 7 to plus 2, that means oxidation state is decreasing. So we can say that manganese is undergoing reduction. Okay, reduction. And what will be the N factor? N factor, that means number of replaceable ions, will be 5, because the difference between plus 7 and plus 2 is 5. Okay, now if we talk about C2O4 2 minus. So in this, suppose each carbon has oxidation state X, then 2 carbons will be 2X. 4 oxygen, that means 4 into minus 2 again. So 2X minus 8 will be equal to minus 2, because the overall charge is minus 2. So 2x equals to minus 2 plus 8, that means plus 6. So x will be equal to plus 6 divided by 2, that is plus 3. Okay. So on the reactant side, carbon has oxidation state plus 3, and on the product side it is CO2. So carbon, X, oxygen, it will be 2 into minus 2, that is minus 4. So x minus 4 equals to 0. So x equals to plus 4. So this time the oxidation state is increasing from plus 3 to plus 4. So we can say that this is undergoing oxidation, not reduction. Okay. So in case of oxidation, the oxidation state increases, and in case of reduction, the oxidation state decreases. Okay. And what will be N factor in this case? N factor will be equal to 2. Okay. Because 2 carbons are there in C2O4 2 minus. Okay. Now, here we know what is the N factor for MnO4 minus and for C2O4 2 minus. So we can find the ratio of N factors. Ratio of N factors will be equal to 5 is to 2. Okay, for MnO4 minus and C2O4 2 minus. And we know that the reciprocal of ratio of N factors give us the molar ratio. Okay, so the molar ratio in balanced equation will be equal to just the reciprocal of ratio of N factors, that is 2 is to 5. What does this mean? It means that if we write the reaction again, let's write it down here. MnO4 minus plus C2O4 2 minus plus H plus, this is the reactant side. Product side is Mn2 plus CO2 plus H2O, right? The same reaction was given in the question. Let's outline it now. So here it means that the molar ratio in balanced equation is 2 is to 5 for MnO4 minus and C2O4 2 minus. So it means that 2 will be the coefficient of MnO4 minus and 5 will be the coefficient of C2O4 2 minus. Okay, so it is clear from here that the second one will be the correct answer, because here it is shown that the coefficient of MnO4 minus is 2 and that of C2O4 2 minus is 5. Okay, so 2, that means option D will be the correct answer. Okay, but we'll also try to find the coefficient of H plus ions. Okay, so let's see. This we can do by balancing the complete equation. So how many manganese are there on the reactant side? 2 manganese. So we'll multiply this by 2 on the product side also, so that we have 2 manganese on the product side as well. Okay, so now manganese is balanced. Now we'll see about the carbon. So how many carbons on the reactant side? 10 carbons, right? 5 into 2, 10. So on the product side also we'll multiply it by 10. So 10 molecules of carbon dioxide. Okay, now carbon is also balanced. Now we'll see oxygens. So how many oxygens on the reactant side? In MnO4 minus we have 2 into 4, that is 8 oxygens. Then in C2O4 2 minus we have 5 into 4, that is 20 oxygens. So total 28 oxygens on the reactant side. That means 28 oxygen should be on the product side as well. So here we have 20 in carbon dioxide, 10 into 2. That means 8 more should be there. So we'll multiply this water by 8 so that 8 more oxygens are there. Now oxygen is also balanced. Now we have to balance the H plus. So how many H plus on the product side? Total 8 into 2, that is 16. That means 16 H plus should be on the reactant side also. So 16 here. That means the coefficient of H plus on the reactant side will be 16. So now it is confirmed that the second one is the correct coefficients. Okay, so option D will be the correct answer because it shows that second one is the correct order. Now question number 70 is from the chapter Equilibrium, and the question is, which of the following conditions will favor maximum formation of the product in the reaction? So this is the reaction, and we have to find the correct condition under which the maximum formation of product will take place. Okay, first one is low temperature and high pressure, second is low temperature, low pressure, third is high temperature and low pressure, and the last one is high temperature and high pressure. Okay, so let's see. If we look at this reaction, we can see that total number of moles of reactants is 1 plus 1. That means 2 moles, okay, on the reactant side. And on the product side, total number of moles is 1 only, okay. 1 mole of X2 is formed. So 1 mole. So we can see that lesser number of moles are there on the product side, okay. Less number of moles. And on the reactant side, it is more. Also, heat is given in negative. That means it is an exothermic process. Okay, heat is released here. Exothermic process. Now, here will you make use of Le-Chatelier's principle in order to answer this question. Okay, Le-Chatelier's principle. So what does this principle say? It says that whenever there is a change in any variable of the reaction, then the equilibrium will tend to shift in a position where it can counteract the effect of that change. Okay, this means that if pressure is increased, suppose pressure is increased, then the equilibrium will shift in a position where the pressure is lesser. Okay, and where the pressure will be lower, where there are less number of moles of gaseous substances. Okay, less number of moles of gaseous substances. Okay, there the pressure will be lower. Pressure is lower here. Similarly, if pressure is decreased, then what will happen? The equilibrium will shift in a position where the pressure is higher. Okay, and where the pressure will be high, where there will be more number of moles of gaseous substances. Okay, gaseous substances. So here the pressure will be higher, right? So here we can see that on the product side, the number of mole is less. Okay, so the reaction is moving towards the lesser number of moles. That means the first situation. So the pressure should be increased in this. Okay, so high pressure should be there. High pressure should be there. Now we have to determine what should be the temperature. So we can see that this is an exothermic process. Exothermic reaction is given here. So what happens in case of exothermic? In case of lower temperature, the equilibrium shifts in the forward direction. Okay, the reaction tends to take place in the forward direction. And in case of higher temperature, it will take place in the backward direction. So this you have to remember. So since this is an exothermic process and we have to make the reaction proceed in the forward direction, therefore the temperature should be low, right? So high pressure and low temperature should be there. Okay, that means first option should be the correct answer. Lower temperature and higher pressure. Question number 71 is from the chapter Chemical Kinetics, and the question is, when initial concentration of the reactant is doubled, then the half-life period of a zero-order reaction is halved, is doubled, remains unchanged, or is tripled. Okay, so we know that for a zero-order reaction, the half-life period, that is T half, is given as A naught, that is the concentration of the reactant, upon 2K. Okay, K is a constant. That means the half-life is directly proportional to the concentration of the reactant. Okay, so when the concentration of the reactant is doubled, then what will happen to the half-life? It will also get doubled. Okay, so the correct option will be option number B. Question number 72 is from the chapter States of Matter, and the question is, the correction factor A to the ideal gas equation corresponds to? Options are density of the gas molecule, volume of the gas molecules, then forces of attraction between the gas molecules, and the last one is electric field present between the gas molecules. Okay, so we know that we have the ideal gas equation, that is PV equals to nRT, right? This is the ideal gas equation. Now, what is the real gas equation? Real gas equation. So in this case, some corrections are added to the ideal gas equation because in reality, no gas is ideal. Okay. So it is also known as van der Waals equation, and it is represented as P plus AN square by V square into V minus NB equals to nRT. Okay, so this an square by an square upon v square is the correction in pressure and nb is the correction in volume. Okay, so what is the significance of a? A signifies the intermolecular force of attraction. Okay, intermolecular force of attraction between the gas molecules. Therefore, the correct option will be option number C. Now question number 73 is from the chapter thermodynamics, and the question is the bond dissociation energies of x2, y2 and xy are in the ratio 1 is to 0.5 is to 1. Delta H for the formation of xy is minus 200 kilojoule per mole. The bond dissociation energy of x2 will be. Okay, so first let's write down the reaction. We have to make xy from x2 and y2. Now, in xy we have only one x, so half mole of x2 will be required. Also half mole of y2 will be required because only one y is there, not y2 is there. Okay. Also the bond dissociation energies are given that they are in the ratio 1 is to 0.5 is to 1 for x2, y2 and xy. Okay. So let's write small x for the bond dissociation energies. Okay, if x2 has the bond dissociation energy as small x, then for half mole of x2 it will be x by 2, right? For y2 it is 0.5, that means it will be x by 2. So for half mole of y2 it will be half into x by 2. For xy again it is 1, that means it will be x only, and we have 1 mole of xy only, so it will be x only. Okay, so these are the bond dissociation energies respectively for x2, y2 and xy, okay, in the given reaction. And it is given that the delta H for the formation of xy is minus 200 kilojoule per mole. So if we add these, that means x by 2 plus half x by 2, that means 1 by 4x, right? Minus x, we'll bring this x this side, so it will be minus x, that will be equal to minus 200 kilojoule per mole. Okay, now we'll solve and find out the value of x. So we'll take the LCM will be 4, so it will be 2x plus x minus 4x equals to minus 200 kilojoule per mole. So 2x minus 4x, that means minus 2x plus x will be minus x, will be equal to minus 200 into 4, that is minus 800. Okay, so x is equal to 800, and we know that the bond dissociation energies of x2 and xy are x, right? That means 800. And what is asked here? The bond dissociation energy of x2, and we know that it is x only, that means 800. Okay, so option D will be the correct answer. Similarly, xy also has x, right? So it will also be 800 kilojoule per mole. If it was asked about y2, then we know that y2 is 0.5, so it will be 0.5 into 800, that means it would be 400. Okay, if y2 would have been asked, but only x2 has been asked, therefore 800 will be the correct answer. So option D is the correct answer. Question number 74 is related to chemical bonding and molecular structure, and the question is magnesium reacts with an element X to form an ionic compound if the ground state electronic configuration of X is 1s2, 2s2, 2p3. This is 2p3. Okay, the simplest formula for this compound is, okay, so what is the electronic configuration of X? It is 1s2, 2s2 and 2p3. So the outermost shell has 3 electrons. That means the valency of X is 3. And we know that valency of magnesium is 2. So the compound that will be formed, that means MgX. So X, valency of X is 3, so it will be 3 here, and valency of magnesium is 2, so it will be 2 here. That means the compound will be of the simplest formula Mg3X2. Okay, so option C will be the correct answer. Now question number 75 is from the solid states, and the question is iron exhibits VCC structure at room temperature. Above 900 degrees Celsius, it transforms to FCC structure. The ratio of density of iron at room temperature to that at 900 degrees Celsius is, assuming molar mass and atomic mass of iron remains constant with temperature. Okay, so M will be constant and R will also be constant. Okay, this is atomic radii. Now, it is given that at room temperature, and room temperature is considered as 25 degrees Celsius to 28 degrees Celsius. So let's say this is 25 degrees Celsius. Okay, it exhibits BCC structure. BCC structure, and we know that in case of BCC structure, the value of Z is equal to 2 and the value of A is 4R upon root 3. Okay, so let's say this is Z1 and A1 respectively. Similarly, it is given that above 900 degrees Celsius, it exhibits FCC structure, and in case of FCC lattice, the value of Z is 4. So let's say this is Z2. Similarly, A2, its value is 2 root 2R. So you have to remember these values, right? And we have to find the ratio of densities in both the cases. So what is the formula for density? It is equal to Zm upon Na A cube. Okay, so M is the molar mass, that is to be remain constant. Okay, and Na is the Avogadro number, so this is also a constant. So let's find the ratio. D at 25 degrees Celsius to the density at 900 degrees Celsius will be equal to Z1 M1. M will remain constant, so let's write M only. Z1 M upon Na A1 cube. Okay, divided by Z2 M upon Na A2 cube. Now M will remain constant, so it will be cancelled. Avogadro number is also a constant, so the ratio will be none. Okay, so it will also be cancelled. So what is left here? Z1 upon A1 cube divided by Z2 upon A2 cube, right? We are just simplifying it. So can we write it like this? Z1 upon A1 cube into A2 cube upon Z2, right? Also we can write it like this: Z1 upon Z2 and then A2 upon A1 whole cube. Okay, now this is the simple form. Now we can simply put the values here. Z1 is equal to 2 as we had already written. Z2 is 4. Then A2 is 2 root 2R, 2 root 2R, and A1 is 4R upon root 3, 4R. So root 3 will go here, and we have to find the cube of this. 2 by 4 is equal to 1 by 2. So here we have 1 by 2, and in the bracket we can solve. R is constant, so let's cancel this also. 2 into 2 is 4. So here we can write root 2 upon 2 into root 3 cube. Again, root 2 into root 2 is 2. So what is left here? Half into root 3 upon root 2 cube. Okay. On solving further, we get half into, what is the cube of root 3? It will be 3 root 3. Okay. And the cube of root 2 will be 2 root 2. So on multiplying this, we'll get 3 root 3 upon 2 into 2, that is 4 root 2. So the correct answer will be, the ratio of densities is 3 root 3 upon 4 root 2. Okay, 3 root 3 upon 4 root 2. That means option D will be the correct answer. Question number 76 is from the chapter Chemical Bonding and Molecular Structure. And the question is, consider the following species Cn plus, Cn minus, NO and Cn. Which one of these will have the highest bond order? Okay, so let's check one by one. The first option is NO. So let's write the electronic configuration of NO. It will be sigma 1s2 then sigma star 1s2, then sigma 2s2, sigma star 2s2, then sigma 2pz2, then pi 2px2, pi 2py2, then pi star 2px1 and pi star 2py0. Okay. So the bond order will be equal to number of bonding molecular orbital minus number of anti-bonding molecular orbital divided by 2. Okay. So bonding are 10, anti-bonding 5 divided by 2. So it will be equal to 5 divided by 2, that is 2.5. Okay. So this is the bond order for NO. Now we come to the second one, that is CN minus. Okay. So let's write the electronic configuration. Sigma 1s2, then sigma star 1s2, sigma 2s2, sigma star 2s2, then pi 2px2, pi 2py2, and at last we have sigma 2pz2. Okay. Bond order will be equal to number of bonding minus anti-bonding, that means 10 minus 4 divided by 2. So that will be 6 by 2, that is 3. So bond order is 3 for Cn minus. Now let's check for the third one, that is Cn without any charge. So the electronic configuration will be again sigma 1s2, then sigma star 1s2. Sequence will be almost same. Okay. Sigma star 1s2, then sigma 2s2, sigma star 2s2. Then next will be pi 2px2, pi 2py2, and at last we have sigma 2pz1. Okay. So this time bond order will be equal to, bonding is 9 only, anti-bonding is 4 divided by 2. So that will be equal to 5 divided by 2, that means 2.5. Okay. And we have the last one, that is Cn plus. So this time we have a positive charge. Let's write the electronic configuration. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, then pi 2px2 and pi 2py2. Okay, that's it, py2. So what will be the bond order? Can you see this clearly? This is pi 2py2. Okay, just to show you clearly. And bond order is bonding minus anti-bonding. So this time bonding is 8 only, anti-bonding is 4 divided by 2. So that will be 4 divided by 2, that is 2 only. Okay. So we can see that the maximum bond order out of the given options is for Cn minus. Okay. So Cn minus, that means option B will be the correct answer. Question number 77 is from the chapter Structure of Atom, and the question is, which one is a wrong statement? So let's see. The first statement says total orbital angular momentum of electron in s orbital is equal to 0. So what is the formula for total orbital angular momentum? It is given by L plus 1 h upon 2 pi. Okay. Now we are talking about the s orbital. So we know that for s orbital the value of L is 0. Therefore, if we put the value of L as 0 in this formula, we'll get the overall value 0. So this is a correct statement. But we have to find out the incorrect statement. So let's move forward. Second statement says an orbital is designated by 3 quantum numbers while electron in an atom is designated by 4 quantum numbers. Again, this is a correct statement because what are the 3 quantum numbers in case of orbitals? These are principal quantum number n, then orbital angular momentum quantum number L, then magnetic quantum number m. Okay, so the orbital is designated by these 3 quantum numbers. Okay. And if we talk about the electron, then in addition to these three quantum numbers, the electron is designated by one more quantum number, that is spin quantum number. Okay, so electron is designated by 4 quantum numbers, right? So this is also a correct statement. Now the third statement says that the value of m for dz square is 0. Again, this is a correct statement. Okay, then the fourth statement and the last one says the electronic configuration of nitrogen atom is. Okay, so what is the electronic configuration of nitrogen atom? It is 1s2, 2s2, 2p3. Okay, so we can see that in 1s and 2s orbitals, electrons are filled and they are paired up. But in the p orbitals, only 3 electrons are there. So all should be in the same direction. Okay, same spin should be there like this, right? And once the pairing starts, then only the direction is reversed. So since pairing is not done in this case, therefore all the directions of all the arrows should be same. So this is the incorrect one, right? So the correct answer will be option number D. Now question number 78 is from the chapter Chemical Kinetics, and the question is the correct difference between first and second order reactions is that. So the first option says the rate of first order reaction does not depend on the reactant concentration. The rate of second order reaction does depend on the reactant concentration. So this is an incorrect difference because the rate of both types of reaction depends upon the reactant concentration. Okay, if we talk about the first order reaction, so in this case, the rate is directly proportional to the concentration of the reactant, okay, or we can say first power of concentration of reactant, whereas in case of second order reaction, the rate is proportional to second power of concentration of reactant. But both depend on the concentration of reactants. Therefore, the first one will not be the correct answer. Now we come to the second one. It says the half-life of a first order reaction does not depend on the concentration of the reactant, initial concentration of the reactant, and the half-life of second order reaction does depend on the initial concentration of the reactant. Now, if we see the half-life that is T half. So in case of first order reaction, it is equal to 0.693 upon K. So yes, we can see that it does not depend upon the initial concentration, right? So the first part of the question is correct. If we talk about the second order reaction, in this case, what will be the half-life? It will be equal to 1 upon K A naught. Okay, so yes, in case of second order reaction, it depends upon the initial concentration of the reactant. So this is a correct difference between both the both types of reactions. Okay, so we have already got the correct answer, but still we'll go through other statements as well. The third one says the rate of a first order reaction does depend on the reactant concentration. The rate of a second order reaction does not depend on the reactant concentration. So it is similar to the first one. The only difference is that in the first one it was said that first order does not depend, and here it is said that first order depends. So it is just the opposite of the first statement. So this is also incorrect because we have already seen that both depend on the concentration of the reactant, right? Now the last one says a first order reaction can be catalyzed, a second order reaction cannot be catalyzed. This is also incorrect because both can be catalyzed. Okay, both can be catalyzed. So we have seen that the only correct statement is option number B. Okay, this shows the correct difference between first and second order reaction. Question number 79 is from some basic concepts of chemistry, and the question is in which case is the number of molecules of water maximum? So we know that the number of molecules is equal to number of moles into Avogadro number. Okay. Also we know that Avogadro number is a constant, so it will remain same in all the cases. That means the number of molecules will depend on the number of moles. So we'll find the number of moles in each of the given cases and see which one has maximum number of moles, right? So let's start with the first one. Here volume of water is given as 18 milliliter. So first we need to find the mass. Mass will be equal to volume into density. So volume is 18 milliliter. Density is 1 gram per milliliter. Okay, this is the density of water. So here we get 18 grams. So mass is obtained now. It is 18 grams. So what will be the number of moles? It will be given mass upon molar mass. Given mass is 18 grams and molar mass of water is also 18. So here we get 1. right? So the number of moles in this case is 1. Okay, 1 mole. Now let's start with the second one. In this 0.18 gram is missing here. Okay, so 0.18 grams of water should be there. So here already mass is given as 0.18 gram. Again we can find the number of moles as given mass upon molar mass. Given mass is 0.18 grams and the molar mass is 18 grams. So it will be 1 upon 100, right? Or we can say 10 to the power minus 2. Okay, or you can also write 0.01 moles. Okay, so this is the number of moles in the second case. Now we come to the third case. Here 10 to the power minus 3 moles of water. So here directly number of moles is given. So in the first case it was 1. In the second case it was 10 to the power minus 2. Obviously second one is lesser than the first one. And in the third one directly number of moles is given 10 to the power minus 3. It is even smaller than the second one. So till now the first one has maximum. Now let's check for the last one. It is 0.00224 liter of water vapors at 1 atmosphere and 273 Kelvin. Okay, so the pressure is 1 atmosphere and the temperature is 273 Kelvin. That means it is standard temperature and pressure. Okay, and we know that at STP, standard temperature and pressure, what happens? The volume, number of moles is given as volume upon 22.4 liter. Okay, so volume is given as 0.00224 liter upon 22.4 liter. Now if we solve this, we'll get 10 to the power minus 4 moles. So we can see that from first to fourth the number of moles is decreasing. So the maximum number of moles is present in the first case, that is 18 milliliter of water. Therefore option A will also have the maximum number of molecules. Okay, so option A will be the correct answer. Now question number 80 is from the S block elements, and the question is, among calcium hydride, beryllium hydride and barium hydride, the order of ionic character is. Okay, so all the mentioned elements belong to group 2. So let's list down all the elements of group 2. First we have beryllium, then magnesium, then calcium, strontium, barium, and at last we have radium. Right, now we have to compare the ionic character of hydrides. Right, so let's write it down here. For second group hydrides, for second group hydrides, we know that on moving down the group, on moving down the group, metallic character increases. Okay, metallic character of metals increases. Therefore ionic character of the metal hydrides also increases. Okay, of metal hydrides also increases. Okay, that means if we move from beryllium to radium, the ionic character of metal hydrides will increase. So in the first option, beryllium, calcium and barium, we can see that first beryllium appears in group 2, then calcium appears, and then at last barium. Okay, so this is on moving down the group, right? So this will be the correct order of ionic character of metal hydrides. Let's see another one, the second option. Here calcium is mentioned first and then beryllium is mentioned. So the beryllium hydride cannot be more ionic than calcium because beryllium appears first. Okay. Similarly, if you compare others also, you will see that these are not in the sequence of going down the group. Okay. So only correct option is option number A. Alright, now question number 81 is related to redox reaction as well as electrochemistry. And the question is, consider the change in oxidation state of bromine corresponding to different EMF values as shown in the diagram below. Then the species undergoing disproportionation is. Okay. So first let's consider the change in oxidation state. In the first one, that is BrO4 minus, the oxidation state of bromine is +7. You know how to calculate the oxidation state? Let's see. For BrO4 minus, suppose the oxidation state of bromine is X. For oxygen it is -2 for each oxygen atom. So for 4 oxygen atoms it will be 4 into -2, that is -8. Okay. So x minus 8 will be equal to minus 1 because the overall charge is minus 1. So x will be equal to minus 1 plus 8, that is plus 7. Okay, so this is how the oxidation state of bromine in the BrO4 minus is plus 7. Similarly, you can find the oxidation state of bromine in BrO3 minus, it will be plus 5. Then in HBrO it will be plus 1. In pure bromine it will be 0. And in bromide ion it will be minus 1, same as the charge. Okay. Now, it is asked which species is undergoing disproportionation. So what is meant by disproportionation reaction? It is a reaction in which the same species undergo oxidation as well as reduction. Okay. And we know that in case of oxidation, the oxidation state increases, and in case of reduction, the oxidation state decreases, right? So in the first one, that is BrO4 minus, the bromine is in its maximum oxidation state. So oxidation state cannot be increased further. So if oxidation state cannot increase further, then oxidation cannot take place. Therefore, it will not undergo disproportionation reaction. Also in the last one, that is bromide ion, the bromine is in its minimum oxidation state, so it cannot be decreased further, so reduction is not possible. So disproportionation is also not possible, because for disproportionation both oxidation and reduction are necessary. Okay, so the only possibilities are BrO3 minus, BrO3 minus, then HBrO and bromine. Okay, only one of these three can undergo disproportionation reaction. Also, we have to remember one thing, that for disproportionation reaction to take place, the reaction should be spontaneous. Okay, reaction should be spontaneous. And how can we determine if the reaction is spontaneous? If the delta G value is negative. And if delta G negative value, delta G will be negative, then E naught cell will be positive. E naught cell will be positive. So here we'll check which of them have positive E naught cell value. Okay. So let's check for BrO3 minus. Now if we move towards right, that means from BrO3 minus to HBrO, the oxidation state is decreasing from plus 5 to plus 1, right? Plus 5 to plus 1. That means reduction is taking place, isn't it? And in case of reduction, the potential is given as 1.5. 1.5. So this is the standard reduction potential. Similarly, if we move towards the left side, that is BrO3 minus to BrO4 minus, in that case, the oxidation state will be increasing from plus 5 to plus 7. Okay, plus 5 to plus 7. So in this case, oxidation would be taking place. And what is the potential given? It is 1.82 volt, and it is the standard oxidation potential. Now we can find out the E naught cell value. It is equal to E reduction minus E oxidation, right? So E reduction is, that is standard reduction potential is 1.5, E oxidation is 1.82. So if we subtract 1.82 from 1.5, we'll get a negative value, right? It is not important to calculate the value, but you should be able to understand that whether the value will be negative or positive. So it is quite clear that it will be negative, okay? And the exact value is minus 0.32. For you, it's not necessary to calculate the value. So it is negative. So it will not undergo a disproportionation reaction, because we know that for disproportionation, E naught cell should be positive, right? Now we'll check for HBrO. Similarly, we'll check both ways, that means towards right as well as towards left. So HBrO to bromine towards right, it is changing from plus 1 to 0 oxidation state. That means reduction is taking place in this case. The value is given as 1.595. 1.595 volt. This is the standard reduction potential. And if we move from HBrO to BrO3 minus, that is towards left, then in this case oxidation state is increasing from plus 1 to plus 5, and the value is given as, this is oxidation, right? Oxidation, and the value is given as 1.5 volt. This is the standard oxidation potential. So in this case, E naught cell value will be equal to, again, E reduction minus E oxidation that is reduction is 1.595 minus oxidation value is 1.5. So this time we are subtracting a lesser value from a greater value, right? So it will be positive. Any value it would be. Let's not calculate it, but we know that it will be positive. Okay. So obviously, in this case, E naught cell is positive, so it will undergo disproportionation reaction. So we have already got our answer, but still let's check for Br2 also. Okay. In this case, Br2 2 bromide, it is 0 to -1, so reduction is there, and the value is given as 1.0652. From Br2 to HBRO, that is towards right, oxidation would be taking place, and the value is given as 1.595. So E naught cell will be E reduction minus E oxidation, so 1.065 minus 1.595. Again you can see that 1.595 is greater, so the overall value will be negative. So the only positive value is in the second case, that is HBRO. Therefore HBRO will undergo the disproportionation reaction, so option C will be the correct answer. Now question number 82 is from the chapter equilibrium, and the question is the solubility of barium sulfate in water is 2.42 into 10 to the power minus 3 grams per liter at 298 Kelvin. The value of its solubility product, that is KSP, will be, and it is given that the molar mass of barium sulfate is 233 grams per mole. Okay, so first we'll find the molar solubility. Molar solubility of barium sulfate, that is S, will be equal to given solubility, that is 2.42 into 10 to the power minus 3 grams per liter, divided by the molar mass of barium sulfate, that is 233 grams per mole. Okay. Now on solving this, we'll get 1.04 into 10 to the power minus 5 mole per liter. Okay, so this is the molar solubility. Now if we talk about the dissociation of barium sulfate, if it gets dissociated, then in aqueous medium it will give two types of ion. First barium ion and second sulfate ion, right? The number of moles are same. So if the solubility of barium sulfate is S, then the solubility of each of the ions, that is barium as well as sulfate, will be S. Okay. Now we have to find out the KSP, that is solubility product. So simply it is the product of solubilities of both the ions. Okay. So the product of solubility of barium ion and the solubility of sulfate ion. Okay, and we know that the solubility of barium is S and the solubility of sulfate is also S. So this is S square. And the value of S was 1.04 into 10 to the power minus 5 mole per liter, right? So the square of this will be equal to 1.08 into 10 to the power minus 10 mole square per liter square. Okay. So out of the given options, the correct option will be option number A. Okay. Question number 83 is again from the chapter equilibrium, and the question is following solutions were prepared by mixing different volumes of NaOH and HCl of different concentrations. So pH of which one of them will be equal to 1? Okay, so let's check one by one. For the first one, 60 ml m by 10 HCl. So 60 into 1 by 10 minus 40 ml m by 10 NaOH. So 40 into 1 by 10, right? So on solving this, we'll get 6 minus 4, that is 2. And in order to find the H plus ion concentration, we'll divide it by total volume, that is 60 plus 40, that is equal to 100. Okay. So 2 upon 100, that will be equal to 2 into 10 to the power minus 2. Now this is the H plus ion concentration, right? So it is quite clear that pH will not come out to be 1 here. Okay. So I'm not solving it further. I'm coming to the second option. It is 55 into 1 by 10 HCl. Okay. Minus 45 into 1 by 10. 45 into 1 by 10 divided by the total volume, that is 55 plus 45, again 100. Now it will be equal to 55 into 1 by 10, that is 5.5, minus 45 into 1 by 10, that is 4.5 upon 100. So it will be equal to 1 upon 100, that is 10 to the power minus 2. Now this is the H plus ion concentration. Again pH will not be equal to 1 because pH is equal to minus log H plus ion concentration. So minus log 10 to the power minus 2 will be equal to plus 2. Okay, so the pH is 2 in this case, not 1. Okay, now we'll come to the third one. It is 75 into 1 by 5 minus 25 into 1 by 5 divided by the total volume, that is 75 plus 25, again 100. So here we'll get 75 into 1 by 5, that is 15, minus 25 into 1 by 5, that is 5 upon 100. So it will be 10 upon 100, or we can say 1 by 10, that is 10 to the power minus 1, right? In this case it is quite clear that pH will be equal to 1. It is minus log 10 to the power minus 1, right? So it will come out to be plus 1. So option C will be the correct answer. Option C, this will be the correct answer. Still, if you want to check the last one also, so we can see, let's see here, D, 100 into 1 by 10 minus 100 into 1 by 10 upon 100 plus 100, that is 200. So here on the numerator side we'll get 0, right? And anything divided by 0 will give the value 0. So this will also not give the pH 1. So only correct option is option number C. Now question number 84 is from the chapter Surface Chemistry, and the question is, on which of the following properties does the coagulating power of an ion depend? So the first option is the magnitude of the charge on the ion alone. Second option is size of the ion alone. Third option is the sign of charge on the ion alone. And the last one is both magnitude and sign of the charge on the ion. Okay. So the correct answer is option number D, both magnitude and sign of the charge on ion. Okay. So this is a direct question. We know that coagulation coagulation of the colloidal solution by using an electrolyte depends on the charge present, that is positive or negative, on the colloidal particle, as well as its size. Okay. And the coagulating power of an electrolyte depends on the magnitude of charge present on effective ion of the electrolyte. Okay, magnitude of charge. Therefore option D will be the correct answer. Question number 85 is from the chapter States of Matter, and the question is, given van der Waals constant for ammonia, hydrogen, oxygen and carbon dioxide are respectively 4.17, 0.244, 1.36 and 3.59. Which one of the following gases is most easily liquefied? So let's write it down here. Ammonia has 4.17, hydrogen has 0.244, carbon dioxide is 3.59, and for oxygen it is 1.36. Okay. Now we know that the van der Waals constant A signifies the intermolecular forces of attraction. Okay. It signifies intermolecular molecular forces of attraction. Now, in gases, the molecules are spread away from each other. But in liquid, they have to be brought closer. So, if already there is higher intermolecular force of attraction, it will be easier to bring the molecules together, right? So, more the value of A, or you can say higher the value of A, higher the value of A, that is higher the intermolecular force of attraction, easier it will be to liquefy a gas. Okay, easier will be to liquefy a gas. So let's see which of them has highest value of van der Waals constant A. So out of the given options, ammonia has the highest value 4.17. So it will be easiest to liquefy. Similarly, if we have to see which will be most difficult to liquefy, so the minimum values for hydrogen, therefore it will be very difficult to liquefy hydrogen. But since it is asked which will be most easily liquefied, so option A will be the correct answer. Question number 86 is from the chapter coordination compound, and the question is iron carbonyl is, options are tetranuclear, mononuclear, dinuclear and trinuclear. So let's see what's the geometry of iron carbonyl. This is the iron, that is the central atom. One carbonyl group here, one this side, and two more, right? CO and CO. So we can see that there is only one central atom, right? Therefore, it will be mononuclear. Mononuclear, because there is only one central atom. Therefore, option B will be the correct answer. Question number 87 is from the chapter coordination compound, and the question is the type of isomerism shown by the complex COCl2En twice is, options are geometrical isomerism, coordination isomerism, linkage isomerism and ionization isomerism, and the correct option is option A, that is geometrical isomerism. Okay, so let's see how. We know that the central atom is cobalt here, and what is the coordination number of cobalt in this compound? Coordination number of cobalt is 6, and the shape or the structure is octahedral. So this is an octahedral complex. So this will show which type of isomerism? Geometrical isomerism. Geometrical isomerism, and it will also be of two types, cis form and the trans form. Okay, what do you mean by cis form? It is the structure in which it is the isomer in which the similar groups are on the same side. Okay, so the similar functional groups are on the same side, or you can say they are adjacent to each other. Okay, whereas in case of trans form, the similar functional groups are on the opposite side. Okay, so similar functional groups on opposite sides. So let's see the structure of this complex. First we'll draw the cis form. Okay, so this is cobalt, coordination number is 6. So 1, 2, 3, 4, 5 and 6. Okay, so here suppose chlorine is at this position, then the next chlorine will also be adjacent to it, suppose here. Okay, and if one En is this side, then the other En will also be adjacent to it on this side. Okay, so the ethylene diamine are adjacent to each other and chlorine are adjacent to each other. So this is the cis form, and we know that cis form is optically active. Okay, this is optically active. And now let's draw the trans form. Again cobalt 6, 1, 2, 3, 4 and 5, 6. Now suppose this time the chlorine is here again, then the other chlorine will be just opposite to it. That means here. Okay, and one ethylene diamine is this side, then the other ethylene diamine will be just opposite to it. So this is the trans form, and it is optically inactive form. Okay, so we can see here that this complex shows the geometrical isomerism. Okay, the cis form and the trans form. So option A will be the correct answer. Now question number 88 is related to D and F block elements, and the question is which one of the following ions exhibit DD transition and paramagnetism as well. Okay, so what is DD transition? It is the shifting of electron from lower energy d orbital to high energy d orbital. Okay, that means the condition for DD transition is the presence of electron in d orbital, right? And if we talk about the paramagnetism, then the condition for this is the presence of unpaired electrons. Okay, so unpaired electron should be present. Unpaired electron, then it will show paramagnetic behavior, right? Now we'll check one by one. The first one is CrO4, 2 minus. Now we'll check what is the oxidation state of chromium here. So the oxidation state of chromium will be plus 6. Okay. How? Suppose this is X for chromium and for 4 oxygen atoms it will be minus 8. So X minus 8 equals to minus 2 because the overall charge is minus 2. So X will be equal to minus 2 plus 8, that is plus 6, right? So here the oxidation state of chromium is plus 6. And what is the electronic configuration of chromium? It is that of argon plus 3d5 4s 1. Okay. Now in plus 6 oxidation state, in plus 6 oxidation state, 6 electrons will be removed. So the first electron, this from 4s, will be removed and 5 more have to be removed. So that those will be removed from 3d orbital. So how many electrons left in d orbital? 0. Okay. So 3d 0 left. That means the electronic configuration will be same as that of argon. So we can say that no unpaired electrons are present. No unpaired electrons are present. Therefore, it will show diamagnetic behavior, not paramagnetic behavior, right? So this cannot be the correct answer. Now we'll check for the next one, that is Cr2O7 2 minus. Again, first we'll find the oxidation state. So here also it will be plus 6, okay, for chromium, and the same electronic configuration will be there. That means 3d0 electronic configuration in plus 6 oxidation state. So it will show diamagnetic behavior, not paramagnetic, because no unpaired electrons are present. Okay, no unpaired electron. Now in the similar way, we can check for third and fourth also. Third one is MnO4 2 minus. So here the oxidation state of manganese is plus 6. Now what is the electronic configuration of manganese? It is that of argon plus 3d5 4s 2. Okay, so 6 electrons have to be removed in plus 6 oxidation state. So in plus 6 oxidation state, 2 electrons will be removed from 4s and 4 more have to be removed. So 4 more from 3d. So that means 1 will be left in 3d. Okay, so the electronic configuration will be 3d1. Okay, argon plus 3d1. That means 1 unpaired electron is present in this case. Okay, 1 unpaired electron is present, also that is d electron. So dd transition is also present, dd transition is also possible, and paramagnetism is also possible because of the presence of one unpaired electron. Okay, so this will be the correct answer. Option C will show dd transition as well as paramagnetism. You can check for the last one also. This is MnO4 minus. Here the manganese has plus 7 oxidation state. So in plus 7 oxidation state, 2 from 4s and all 5 from 3d will be removed. So the so the electronic configuration in plus 7 oxidation state will be that of argon plus only that of argon. Okay, because 3d 0 is there, no d electrons. Therefore, no dd transition or no paramagnetism will be there. Therefore, only option C is the correct answer. Question number 89 is from the chapter Coordination Compound, and the question is the geometry and magnetic behavior of the complex nickel tetracarbonyl are. Okay, so we know that carbonyl does not contain any charge, so the oxidation state of nickel is 0. Okay, now what is the electronic configuration of nickel? Electronic configuration is 3d8 and 4s2, okay, of nickel. So that means how many orbitals in D? 1, 2, 3, 4, 5. Okay, 5 d orbitals are there. So here 8 electrons are there. That means 1, 2, 3, 4, 5 and then 6, 7, 8. Okay, and 4s 2. So this is 4s, 2 electrons are there. 4p is 0 electron. No electron in 4p orbital here. Now, what will happen? Carbonyl group is a strong field ligand, isn't it? Strong field ligand. Therefore, it will transfer the two 4s electrons in the 3d orbitals. Okay, so these two 4s will be transferred in 3D orbitals. So let's see what will happen. 1, 2, 3, 4, 5. These are 3D. This is 4s, and here we have 4p. Okay. So we already had 8 electrons in 3D orbitals. 1, 2, 3, 4, 5, 6, 7, 8, and 2 more electrons have been added here. Okay. So 1, 2. Now this 3D orbital is completely filled. Okay. And 4s and 4p are empty. Now the carbonyl will donate its lone pair in the empty orbitals, right? And how many lone pairs? 4 lone pairs of electrons, because 4 carbonyl groups are there, right? So one lone pair in this 4s, then 3 lone pairs in the 3 4p orbitals, okay, will be donated by the carbonyl groups. So total 4 lone pairs of electrons. Now what will be the hybridization? Due to this, the hybridization will be sp3, and we know that sp3 has tetrahedral structure. Okay, tetrahedral structure. So the first one will be that it will show tetrahedral geometry. So either B or C is possible. Now we can see that no unpaired electrons are visible anywhere, right? Can you see any unpaired electrons? No. These are paired up completely. Therefore, no unpaired electron means that they will be diamagnetic in nature. Okay, diamagnetic in nature. Therefore, option B will be correct. If there would be some unpaired electron, in that case it would be paramagnetic. But since no unpaired electrons are there, so it will be diamagnetic. So option B will be the correct answer. And now the last question is from the chapter D and F block elements. And the question is, match the metal ions given in column 1 with the spin magnetic moments of the ions given in column 2 and assign the correct code. Okay. So the first one is cobalt 3 plus, right? Now what is the electronic configuration of cobalt? It is that of argon plus 3d7 4s2, okay, in zero oxidation state. But in plus 3 oxidation state, 3 electrons will be removed. So 2 of the 4s electrons will be removed and 1 from 3d will be removed. So how many will be left? This will be the electronic configuration 3d6. Okay, so we can see that there are 6 electrons in the d orbitals. So let's see here, we have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 and 1 electron will be paired. So how many unpaired electrons? 4 electrons. Okay, so number of unpaired electrons will be 4. Now we can find out the magnetic moment, right? Spin magnetic moment, that is given by the formula under root n plus 2. So putting the value of n as 4, we can get 4 plus 2, that is under root 24. Okay, so the correct match for A will be number 4. Now we come to the second one, that is Cr3 plus, chromium 3 plus. Now the electronic configuration of chromium is that of argon, then 3d5, 4s1, right? In 3d plus, in chromium 3 plus, 3 electrons will be removed. So 1 4s will be removed and 2 from 3d will be removed. So how many will be left in 3d? 3 will be left, right? So it will be argon, then 3d3. So let's fill the electrons. 1, 2, 3, 4, 5. So three electrons are there, 1, 2, 3. Therefore, the number of unpaired electrons will be 3. So the magnetic moment will be under root 3, 3 plus 2. That is equal to under root 15, right? So the correct match for B will be number 5, that is under root 15. Now we come to the third one, that is Fe3 plus. Now electronic configuration is that of argon, then 3d6, 4s2. Now in 3 plus, 3 electrons will be removed. So 2, 4s will be removed and 1 from 3d. So 5 will be left in 3d, right? So it will be argon, then 3d5. That means all the electrons will be unpaired. 1, 2, 3, 4, 5. Okay, so number of unpaired electrons will be 5. So the magnetic moment will be under root 5. 5 plus 2. Okay, that means under root 35. So the correct match for C will be number 2, under root 35. And we have the last one now, nickel 2 plus. The electronic configuration is argon, then 3d8, 4s, 2. 2 plus, that means this 2 4s will be removed. So what will be left? Only 3d8 will be left. Okay. So we have 5 orbitals. 1, 2, 3, 4, 5. Then 6, 7, 8. So these 3 are paired and 2 are unpaired. Okay. So the number of unpaired electrons will be 2 in this case. And the magnetic moment will be equal to under root 2, 2 plus 2. Okay. So that is equal to under root 8. That means option number 1. The correct match for D will be number 1, that is under root 8. Okay. So out of the given matches, the first one is the correct match, right? So if we scroll down here, the first is shown in option number C. So the option number C will be the correct answer. Okay. So here we complete all the questions from NEET 2018 paper. I hope you got the concepts well. Okay. And for a better understanding, you can practice the questions from our website www.examsnet.com. And for more informative content, you can download our app from the link given in the description. Okay. So we'll get back in the next session. Till then, keep learning, keep scoring high. Thank you so much.